very good morning to all of you. I hope I'm audible.
Yes.
So very good morning to all the delegates and the speakers today, and a very warm welcome to the second edition of our virtual conference on bridge construction in Asia. My name is Akanksha, and I, along with my colleague Ishita Gupta, will be hosting as well as moderating this conference over the next 2 days. We are now ready to begin with our today's proceedings. And before we begin with the first session for the day, I have a brief presentation for you. Basically, talking about the mission and background with which we have, for which we are holding this particular conference. Just give me a minute to share my screen. Ansi, can I get the screen right?
Yes, you have the right.
I hope my screen is visible to all. As I mentioned, that this is the second edition of our virtual conference, and this year the theme is progress and opportunities, new technologies, and best practices.
Hi, Akansha, the screen is visible. You just need to put it on slideshow mode.
Yeah. Is the slideshow visible right now?
No, I think so. There is a slight of delay, but it does not come up yet.
Let me just reshare my screen. Ladies and gentlemen, just allow me a moment to reshare my screen. Is this visible now, Ansi?
Yes, it is visible. Yeah. Thank you.
So a very quick background about this conference today. Asia is home to many of the world's longest bridges and has a strong pipeline of projects coming up in the future. Much of it is being driven by the increasing urbanization and bold infrastructure programs of the region's developing economies. China has witnessed a big leap in bridge construction. The country has made constant improvements in bridge design and construction practices. In August 2021, the first cross-river bridge between China and Russia was completed. India too is coming up with many new projects, including bridge construction. It has commissioned a few noteworthy projects, such as the Bogibeel Bridge in the state of Assam, Signature Bridge in Delhi, and the Bandra-Worli Sea Link in the state of Maharashtra. The country is also ready to commission the world's highest railway bridge over the Chenab River in Jammu and Kashmir. The Southeast Asian countries are constructing many new bridges and roadways and railways projects. The State Railway of Thailand is coming up with a bridge across the Mekong River to connect the provinces of Nong Khai and Lao. This new bridge is expected to support cargo transport through Thailand, Laos, and China on the transnational railway. Cambodia has also launched a bridge and road project last year in Troy Co Kampot City. In July 2021, the 506-meter four-lane bridge Estrella-Pantaleon in the Philippines was open to traffic, while the 32-kilometer Bataan-Cavite interlink bridge project is expected to be completed in 2023. In Myanmar, construction work is in progress on the $168 million Korea-Myanmar Friendship Bridge called Dala Bridge project. Overall, the region is seeing increasing use of pre-constructed, prefabricated, and pre-engineered products in the bridge construction process. This has led to reduction in execution time and increase in the quality of bridges constructed. Japan has extensively used the pre-stressed concrete technology for bridge construction. Going ahead, there is significant scope for innovation in bridge maintenance and safety. The concerns about maintenance and monitoring of bridges have become a big challenge, and there is a need to build more reliable and robust structures. structural health monitoring, including the aspects of public safety, prediction, and prevention of structural issues, and budget optimization for bridge maintenance are now emerging as key focus areas in the most Asian countries. The mission of this virtual conference is to understand the emerging trends and developments, discuss the opportunities and challenges, and highlight the latest construction techniques, methods in the bridge construction market in the Asian region. The conference will also highlight the technologies and best practices in bridge design, engineering, and construction, as well as showcase noteworthy projects and address several questions, some of which are: what are the key trends in market size in the bridge construction sector? The current construction techniques and best practices in this space, the key challenges and lessons learned by various projects, experience of contractors in bridge construction projects, new and emerging technologies in this sector, current design and engineering practices that are being followed, a little brief of some of the noteworthy projects, what lessons can be learned from these, the role of technology in bridge rehabilitation and asset management, and what are some of the new innovations and advancements for bridge maintenance and safety. The agenda or the structure of this conference is such that over the course of 2 days, we've planned about 14 sessions for you, in which we hope to get answers for the questions that I mentioned right now, as well as listen to the speakers on the sessions, which are namely trends, developments, and outlook. We will have a session on Philippines focus, where we'll hear about their experience, best practices, and challenges. There'll be a session on Underdeck access and netted safety solutions for bridge construction and repair, a project showcase on Chenab railway bridge construction, innovative designs adopted in the 19.3 kilometer long Brahmaputra bridge, bridge projects in the GCC, some case studies there, a project showcase on the Petarani project in Indonesia, another project showcase on Cebu-Cordova Link Expressway, a session on focus on integration of survey plus BIM for bridge, which is essentially digital construction, a session on Australasian experience on the use of weathering steel bridges, a session on focus on methods of bridge construction, Sri Lanka focus, where we'll talk about bridge construction project over the Kelani River, a session on bridge repair and rehabilitation, and another session on bridge construction experience, challenges, and key learnings. I'm very happy to announce that this conference has attracted a diverse group of top and middle level managers who are representing construction companies, EPC contractors, design and engineering firms, consultants, highway developers, equipment providers, O&M companies, material manufacturers, technology providers, GIS and BIM solution providers, investors, financiers, and various multilateral organizations, etc. A little about us. India Infrastructure Publishing is a company which is dedicated to providing information, analysis, and insights on the infrastructure sectors in India. We publish 7 magazines, one of them being global, and most of these have an online version as well. We organize and conduct more than 50 conferences in a year, both in India and abroad. We undertake more than 35 multi-client studies and research reports annually. We work on 15 plus high-end, in-depth custom research solutions in a year, produce 10 plus weekly newsletters. We also operate 2 online databases by the names of India Infra Monitor and India Power Regulation. We operate 2 global information portals as well, a platform in the name of India Infra Forum, and we produce 10 plus sectoral directories a year. Some of the distinguishing features of our virtual conferences are that the conferences focus on dissemination of information, sharing of expertise, and exchange of views. Schedules are being adhered to, and we strive to provide adequate time for discussion. This conference is sponsored by Web Systems International, and we thank them for their support. We are now ready to begin the day 1 of our conference. And as you can see that the first session is going to be on trends, developments, and outlook. And we have with us Dr. Alex Chong here to present in this session. He is Technical Director with Aurecon. Before I introduce Dr. Chong for our delegates here, I just have a quick announcement to make. The structure of the session would be such that Mr. Chong will be making his presentation first, and then we'll be taking up some questions from the delegates. So my request to all the delegates is that please key in or type in your questions in the chat box or in the Q&A box while the session is in the progress, because that will help us take a lot more questions in the end. And that will also leave Dr. Chong with a lot of time to give detailed answers to all those questions. Before I request Dr. Chong to present his slides, I will quickly introduce him for our audience today. As I mentioned, Dr. Alex Chong is Technical Director with Aurecon. He comes with 23 years of experience in the field of advanced structural analysis and design of complex and special structures under static and dynamic load conditions. He specializes in computational analysis of civil and mechanical structures using the advanced linear and nonlinear finite element methods. Dr. Chong has led several complex engineering projects in Asia, like conducting the erection analysis of the West Kowloon Station long span roof structure, leading the detailed design for the Macau Eiffel Tower, and tender and construction stage design of the Artist Square Bridge. He has led 2 technically challenging pre-stressed concrete viaduct assessment projects for the Hong Kong Highways Department as well. Welcome, Dr. Chong.
Thank you, Kansha, for the introduction. Yep. Shall I begin the presentation?
Yes, sir.
Okay, I'll try to share my screen right now. Just give me 1 second. Let me know if you can see my screen.
It's visible. I would request you that, we have about 17-20 minutes for the presentation, and we'll spend another 5-7 minutes to address the questions from the delegates.
I've got a fair bit to cover, so let's see how it goes. I might skip some slides. Okay, thank you for the introduction, and I'm very honored to be here to present in this conference in the first session on trends, development, and outlook. And I would say that this is my perspective. I hope that you'll find this presentation useful. Okay, so without further ado, so I will start by sort of giving an introduction and some background of why we are talking about this topic here. Okay, just moving in. So we are talking about bridge construction in Asia, and it's all about, I would say, connectivity. So we would like to connect different regions of the country, different cities, and also eventually the ultimate goal is to connect the people. And one of the reasons that we are seeing in this region for the demand on highways and bridges construction is really the population growth. If you look back in the last 50 years, it got very, very high growth rate of population in this region in Asia. And it's more than anywhere else in the world. And this is a picture, a very famous picture of Hong Kong. People live in very crowded space, and the people are demanding for better connectivity. And especially, I think the biggest challenge is it's actually, rather than just looking at the rural areas, the challenges also lies within the built-up urban region as well. So all in all, what it means to us in terms of building better connectivity is to improve economic growth, and this is a very I believe is very, very familiar sort of scenery, I think, to all of you. I think in Asia, I think if you live in a very busy city, so you get to see in the peak hours that bridges are filled with traffic, and then you can see different multi-layer of bridges as well. So eventually, what we're talking about is basically providing better connectivity. So this is all what we're talking about here. I think building bridges is to sort of bridge the people, bridge the city. So just quickly going through the agenda, I made an introduction. So I'll get into the key trends and development, especially in this region. And then I'll touch on the recent advances, innovation, and also take a peek of what will happen in the future from my perspective in bridge design and construction. And at the same time, while I'm talking about this aspect, I'll be throwing in a few case studies as well to illustrate that. And I'll wrap up the presentation with a conclusion. Okay, looking at the key trends and development. So just I think we're talking about Asia. I think exactly what you have talked about, Akansha. I think Asia is the home to many of the world's longest bridges. So if you take another look and take a step back, what is driving that? It's because we are experiencing increasing prosperity in this region, and we are having a very high growth economic growth rate in this region as well. And then that sort of drive that we have a very bold aspiration in building bigger and longer and more effective infrastructure. So if you take a closer look, I think there's a table on the right there that shows the top 10 longest bridge in the world. As you can see, 9 out of 10 of these bridges are located in Asia. That's amazing to see that. That is really, I think, what is propelling the demand in building more bridges in this region. So if you look at from a slightly different aspect, I think we looked at the length of the bridge, not just the length, the total length, but we also looking at bridges with larger spans that get built in this region as well. So, for example, looking at suspension bridge and also the cable bridge type, I think these two type of bridge provides the sort of the longest clear span to the bridges. And similarly, if you look at the trends, is that I think the highlighted ones are those ones located in Asia. And again, that demonstrates the demand. And one interesting observation is that the completion year of these bridges are fairly new. So compared to other regions, they're built in some in the 30s, in the 60s, or in the 80s. But what we're seeing in this region is that we're having the demand or the need or to build or propel the building of new bridges. So that is what we sort of see right now here. So altogether, I think building bridges is to improve connectivity. There are different ways to improve connectivity, looking at different sort of components of it. For example, development of a new road network, or either building new highways, bridges, or transportation hubs. So if we look at this individual item separately, for example, highways, if we are not looking into just building new bridges, one of the ways to increase capacity and improving connectivity is by providing more capacity to our existing highways through widening and improving junctions. And some of other ways to do it is that I think if you build your roads on ground, and if your demand has increased and you need more capacity, you can look into building up in the vertical sense, that adding a second layer or even the third or the fourth layer. That's what we see in the first few pictures that I showed in the beginning. And we also introduced smart technology in these bridges or asset. So bridges, it's a very important component in connecting highways at different points. So in order to add capacity, we would be adding extra lanes. So that would be the engineering problems of how we add the extra lanes in the existing bridges. And some other ways that we can do it's by having getting or justifying extra capacity without widening, by carrying out bridge-specific assessment of the live loading. For example, the diagram down there, I think the bottom right, it's the Anzac Bridge, that we carry out a specific load assessment on this bridge to get more capacity. And adopting digital technology as well in controlling traffic on the bridge, and also designing longer and more efficient bridge that requires less maintenance. If increasing capacity is not sufficient, then we look into building new road networks, and that will form part of the overall strategy development of a country or a region. And the suspension bridge that shown on screen there, it's actually the Route 11 road network that we sort of conducted with a study, I think a feasibility study with that bridge. It's a suspension bridge of about 1.2 kilometer long span suspension bridge. And lastly, I think when you have a good road network, you have to look into providing transport integration hubs that allow people to change from one mode of transport to the other. And looking a bit further, I think in the future, you'll be getting autonomous vehicles. I mean, in fact, you are already having autonomous vehicles on the road. For example, Tesla, they have the function of driverless driving, but it's not mature yet to be actually sort of used widely. But actually having this sort of autonomous vehicle means that you need different facilities like depot, repair factory, and such. And also bridges are becoming more multi-purpose that facilitate the use of different modes of transport, for example, cars together with railway and so on. So just zooming into the aspect of bridge widening, one of the more traditional way of bridge building is by using precast beams, and that it's very widely used since the 70s, and then bridges all around the world, including Asia. I think for those with a span of about 15 to 30 something sort of meter span, you can recognize that I think that they're mostly built with this technique of construction. So, I mean, naturally, I think for bridges built with this construction technique for widening, you'll be widening using normally the same technique. So for this bridge, widening part of the bridge is simply by lifting the additional precast beam onto your, for example, strengthened crosshead or the widened crosshead, and then lift it up by either using lifting crane or launching gantry, stitch it to the structure. But the challenge is that it's not easy to carry this out in an urban environment. So this is just an example of widening in Australia, and widening is very widely. It's very common in Australia, and I can see that. I think the trend in the future is that I think in Asia, I think we probably have been looking into building new bridges, and in the future, I think especially with the limited space available, I think bridge widening becomes very widely used. So, for example, in this case, that the two individual bridges that you can see on the screen there, it's actually stitched together by adding new piers as well as adding new precast beams. And if space is not enough for widening a bridge or a road, so the other option that we can look at is to provide double deck highways or even triple deck or even more level of decks. So that is also becoming a trend as well. So in this case, it's basically, I think, identifying the right space to have your piers and foundation to build your bridge above. And then the challenge again, I think, in an urban environment, busy road, the challenge would be to build this new highway. And then the requirement is really to look into using more advanced construction technique. An alternative method to precast beam is the use of precast segmental construction method. So this method, it's beneficial over the precast beam method, is that you cast or you prefabricate your box in the factory and you bring it on site and stitch together. So for the precast beam method, you will need to cast the slab on the top, and for this one, you're basically removing the need of casting the top slab. Okay, moving to the next part, I think I would like to talk about advances, innovation, and peek of the future into the future. So there's a lot of aspects in this topic. I'll just focus in a few ones that I think are important, and we can discuss about this. So the first one that I want to look into is the design of interchange. And as you know, interchange is important. It's basically, it's the node for the traffic to be connected together, and also facilitating diverting of traffic into different directions. So it has to be done properly, otherwise it will become a bottleneck. And normally when you get an interchange design, you get tight radius of curves. And then normally they are not suited to precast beam construction. Just imagine if you want to use precast beam that is laid out in a straight manner, that you will be requiring many piers that are very closely spaced, and which is not viable economically and also sort of efficiency-wise. So in terms of the construction, I think the widely used construction technique is the precast segmental construction using balanced cantilever approach. So what I've got on the screen there, it's a project that's nearly finished in Hong Kong that we've designed in a design and build contract. With the contractor, we developed the segmental construction with balanced cantilever approach. One of the benefits of this kind of bridge is that you can reduce the number of bearings, and the deck is normally a monolithic or cast together with the pier. At the same time, you reduce the number of expansion joints as well. That reduce the need for future maintenance massively. What is really driving the use of this technique is the increase in computing speed, computing power, as well as the availability of advanced analysis tools. And the designer can actually use the computational tools to basically simulate the construction approach or construction staging in the analysis model. And then you can use the design model the analysis model to carry out design and to look at, I think the most important thing is to integrate what happens in construction into your design of the permanent structure, because that's important for this kind of bridge construction. So you can use the model to assess whether the bridge is overstressed in the permanent state as well as the construction stage. And finally, this model can be used for carrying out geometry control. So this just sort of gives you a glimpse of the model that we created. I think this shows the final model, but actually the model is actually built up stage by stage, activating the segments of the bridge. And then that's why you can see the deflected shape on the right there. It looks a bit awkward in the displacement, and that is the total displacement. And then you can see the cantilever. And what happens with this displacement or the incremental displacement is that it's actually taken into the development and precamber for the construction that assists the construction, the stage by stage construction. And then in the final constructed bridge, you wouldn't be seeing this deflection because it's already accounted for in the step-by-step precambering. And then the next topic I want to look into is efficiency in design process. I think designing a bridge up to constructing a bridge is a very complex process. That there will be involvement of many stakeholders in it. Normally, I think for traditional sort of design processes, that the highway engineers will come up with the alignment, and then the alignment will get passed to other parties. For example, the bridge designer starting to develop the analysis model, then to design and for documentation and so on. So just imagine what happens. I think especially in the early stage, that someone came and changed the alignment, then you have to go through all the process again. I think it's very time consuming. So in this sort of rapid changing world, that I think a flexible design method is important. And what we are using, I think, especially in our team, or it's also becoming a trend, is parametric design. In a parametric design, what it means is that I think you don't really do it in a linear way, as I just described. You basically set out the workflow digitally. Now, I'm just going to give you an example. I think this is an extra doors bridge that we are developing in Hong Kong right now. I'm not going to mention the project because it's confidential. It's an extra doors bridge that supports a railway line on top of it. So behind the screen, that you see the boxes with the lines connecting to each other. That is the parametric design environment. So you basically use visual scripting to develop the workflow. So from taking the geometry from the third party and then into developing your model into your spans and piers, and then also inputting your materials and your section properties and so on, and loading, and then spit out the design model or the analysis model. So this slide shows pretty much the workflow. That step number one is taking input parameter. It either can be in an Excel format or Grasshopper that I haven't mentioned. That is the environment that we use for parametric design. It's actually one of the modules in Rhino, if you are familiar with all these modeling tools. Then in Grasshopper environment, you develop the workflow that's shown in number 2 here with all this scripting. And then finally, I think through the scripting, we export it to Midas Civil, and that's the analysis program we use for design and analysis. So the beauty of this is that I think anyone that come and change the section size, the alignment, all the changes can be done in the workflow, and then the analysis model and the design model will be generated very rapidly. So you don't need to go through the linear process again. So just imagining, I think this is the first sort of iteration. You get a straight alignment, and someone comes in and say, okay, let's see, I want to push the bridge to the left and a bit to the right there. And once you set up the workflow in a matter of probably hours or so, or probably half an hour, you get an updated model to facilitate the next step of design and analysis. So the same techniques is applied to another project as well. I think this is a project in New Zealand, in Auckland, called the Northern Pathway. It's actually a new bridge would like to be built by or designed or developed by the client just next to the Auckland Harbour Bridge. So we use the same technique to set up the process, the workflow, the design workflow. And then we very rapidly develop a box version of it as well as a truss version of it. And then for each of these versions, we can change the parameter very quickly, for example, the depth or the span or all sort of things. And that actually accelerated the entire design development process. The next thing I want to talk about is advanced construction technique. And we talked about, I think, Akansha also touch on, I think, the different techniques that it's required to build new bridges in a rapid way. So what we are seeing here that is these 3 bridges were constructed, I think, just recently in Hong Kong. They are footbridges. I think it's quite interesting that I would like to put it in the slideshow that to show you. I think one of the bridge on the left is built or fabricated completely on one side of the road, and it get pushed into the existing building completely as incremental launching. It's actually not very widely used in Asia, but it's actually sort of getting more and more common. And the one on the top right, it's a bridge that's built above a new development, completely over the new development and get rotated to the other side. This is really interesting. And the bottom one, it's quite unusual as well. It's an arch bridge, but it's built in 2 parts, vertically up and then gets rotated down onto the horizontal position. And the one on the left, it's actually one of our projects. So I have very heavy involvement in that. And one thing I want to point out with this sort of construction technique is that it has to be integrated in the design development. So it's not just the responsibility of the contractor, but actually the designer has to be a big part of the development of the construction, as well as integrating all of this in the design. And the video at the bottom right there, you can see that the bridge gets actually pushed backward because of, I think, to solve some of the limitation of site availability of site space there. And after the bridge is assembled, then it pushed to the right side into the other side of the road. So another aspect I think I want to touch on is bridge maintenance. As we know that I think bridges in Asia is much younger than bridges in Europe or in the US, especially if I look into the type of bridge post-tension concrete bridges, pre-stressed bridges that Ankasha also touched about just now. I think if you look into the experience in Europe and US, these bridges are built in the 70s or so, or the 80s. And then 20 years later, a lot of problems emerge near the end of 1990s. And these bridges are actually sort of, if you're familiar, it's made of tendons that is within a duct, and then within the duct you fill it with grout. And then a lot of the problem is due to corrosion of the strands within this duct. And normally when you put strands or tendons in this duct and then you fill it up, people just forget it. After 20 years, I think this sort of problem emerge. Yeah. And in some cases, you see tendons snapping. It's completely broken. Or you sometimes see that the less serious ones, you might see the cracking in the duct. And what I want to point out is that in Asia, these bridges get more widely used in around year 2000. It's now about 20 years later, and we can sort of forecast that this sort of similar problem might be emerging soon in this area as well. It's not in Hong Kong. It's not dissimilar. I think we are seeing some bridges that is experiencing similar sort of problem. So the thing, what can we do? I think what we normally, I think we can go out to site. I think with this existing bridge, we carry out a tapping survey on the post-tension these tendons and to see whether there's any void in it. And then you can also install acoustic monitoring to monitor any strand breakage or wire breakage. And if the bridge can't really be repaired by sort of grouting it back, you have to carry out a tendon or detensioning of the tendon and tendon replacement. And what is also driving the change in the design practice is that I think the adoption of monostrand tendon in place of multi-strand tendon, pre-stressing tendons. The reason is because I think for these monostrand tendons, the strands can be replaced individually instead of taking the entire tendon down, which is a dangerous and also a very tedious process. On sort of the last topic I want to touch on is structural health monitoring. We all know that for critical or important bridge structural health monitoring, it's a must. And what I will sort of see in the trend in the future is that because we collect so much data out of structural health monitoring, a big part of the problem is how you interpret this result and make a rapid action against it. And also a lot of the time is that you collect a big set of data and you analyze it, you find that that's a problem, then we get into repair it, that becomes a reactive process. So what will be the trend in the future is that we can make use of machine learning and the AI system to sort of analyze the data for us and train also the machine learning system to recognize issues. Apart from just telling us the problem is coming up, the machine learning system would be able to sort of predict what might be coming out when it sees a trend that the system is collecting. So it becomes a sort of a predictive measures rather than a sort of passive or reactive measures. And then so that there are challenges with this because I think we're still sort of using the traditional way, but I think if we can sort of start putting our mind to it and sort of see how we can apply machine learning into our, I mean, bridge building is one of the oldest sort of engineering discipline. I think we have to apply new techniques to it, and it will actually be a great benefit to our industry. Finally, just conclusion, I think we see economic growth in Asia, and that will sort of keep propelling the need for new bridges, highways, or widening of bridges. So widening is going to be a big topic as well. So it's something that we have to start thinking about the construction technique or training up the industry to be able to do such widening practice and also in terms of the design and construction method, we have advanced a long way due to the development of new advanced analysis tool as well as increasing computing powers. And bridge maintenance, because of the age of our bridges is getting to, it will become a key topic in coming years. And finally, I think we would like that our bridge to be smart. We like that our bridge that will be able to think by themselves by integrating machine learning and artificial intelligence, so that we'll be able to predict issues in advance. Okay, I think that's all for my presentation. I hope you find it useful. I'm happy to take any questions or comments.
Thank you so much, Dr. Chong. Thanks a lot for a very comprehensive presentation. We do have a couple of questions for you. I will just read out them and we'll just let you know what those questions are. So from one of the delegates, so the question is that you spoke about precast girder elements. So, this is Mr. Van Farm, and he would want to know if you can elaborate on how many maximum length per one span is there.
Can you repeat the last two sentences, the question?
Yeah, so he's written that I saw the precast girder elements. Could you please share with us how many maximum length per one span is there?
Okay, normally for precast girder, I think if you're talking about normal strength concrete, I think it's span probably about 20 to 30 something meters. That's for one span. So I think that there is also something that I didn't touch on. It's actually, I think that's also a trend of using ultra high performance concrete. And especially I think in Malaysia, I think this technique has been applied on quite a number of rural bridges. And then the span of this precast girder can be up to, I think, 50 or 60s or even more. I think that's really, I think, the efficiency increase. But the technical challenge of that is with ultra high performance concrete, you don't really get a very developed sort of design standard or code that you can follow. But of course, I think we can keep using the sort of the normal precast girder method.
Right. I think he specifically wanted to ask that what is the typical length for precast girders that Aurecon is using in the structures that it is designing in Hong Kong?
Yeah, I think it's, I think normally 20 something to 30, that's sort of the sort of span length, yeah.
Okay. So, sir, we have another question from Ansi Anthony, and the question is, what is the maintenance strategy adopted in Hong Kong for management of bridges?
Yeah, I think we have a highways department in Hong Kong. I think normally all the bridges that get built and then at the end will be handed over to the highways department, and I'm quite sure it's similar to many other countries as well. So this the highways department in Hong Kong, they have the maintenance team that they will carry out maintenance inspection at a very regular intervals. And depending on the type of bridges as well, for example, I think the bigger ones like that's a big suspension bridge in Hong Kong, Chenab Bridge. I think that is a bridge with very extensive sort of structural monitoring system installed in that bridge that sort of monitor exactly what is happening with the health there. So strain gauges, vibration monitoring, acceleration, all sort of things that gets fed to an analysis center to look at the data continuously. But normally for highway bridges, you don't really have that, but actually the maintenance strategy is normally by a regular inspection. And I think with the two projects that I was involved in recently on, it's actually a precast segmental construction, the bridge with a post-tension tendon. I think issues were identified, I think, in some of these tendons, and I think things like tapping and stuff like that, it's actually carried out to identify or to make sure that I think bridges of similar type are in good health. I think it's still sort of a reactive sort of approach that Hong Kong is taking. But I think as we go, I think we have to sort of start thinking about integrating new technology into health monitoring so that we can react to problems more quickly.
All right. Dr. Chong, with that, we will close the session. Thank you so very much for your time and for a very comprehensive presentation. I would request all the delegates that in case they have some more questions for Dr. Chong, you can probably send it to us and we'll try forwarding it to Dr. Chong for responses on that. Dr. Chong, thank you so very much for your time today. And I would request you to please stay along because we have some other sessions here and you can listen to our other speakers as well.
Thank you very much, Ankasha. I think the audience will find it useful. And it's really my privilege to be here with you all. Okay, thank you.
Thank you. Have a good day. Thank you. We are now ready to begin with the next session for the day, which is on Philippines focus, experience, best practices, and challenges. And for that, I have with me Dr. Edwin C. Matanguan, who is Director, Bureau of Design, Department of Public Works and Highways, Philippines. Welcome, Mr. Edwin.
Thank you.
I'll just take about 30 seconds to quickly introduce you to our delegates here, sir, and then you can present.
Can I proceed now?
So you can share you can share your screen, but I'll just take about 30 seconds to introduce you to the delegates before you begin.
Yes, please.
Yeah. As I said, Mr. Edwin is the Director of Bureau of Design at Department of Public Works and Highways in Manila, Philippines. He comes with more than 40 years of experience with the Department of Public Works and Highways, which he joined since 1982. Previously, he headed the Bridges Division of the Bureau of Design for about 30 years. He is involved with the design preparation and review of major bridge projects in Philippines. Mr. Edwin is a graduate of Science and Civil Engineering from Mapua Institute of Technology, Manila, Philippines. Welcome, Mr. Edwin.
Thank you so much, Akansha.
Yeah.
Good morning, everybody. Good morning, Akansha. And thank you for inviting us in this second edition, Bridge Construction in Asia. Just a brief introduction. This country's infrastructure development has taken great strides over the past 6 years under the Duterte administration under the Build program of the government, the so-called golden age of infrastructure in this country. As our Department of Public Works and Highways Undersecretary Emil K. Sadayan would say, and I quote, "This was undertaken with an understanding that economic activities cannot be conducted efficiently without adequate infrastructure." End of quote. Therefore, with the continuing efforts of the government in its infrastructure program, are the infrastructure preparation and planning facilities being facilitated by the Department of Public Works and Highways, which includes, among many others, long-span inter-island iconic bridges. One of which you mentioned, Akansha, in your introduction, is the Bataan-Cavite interlink bridge project to be constructed across Manila Bay, which is one of the flagship projects by the Build program in the Philippines. At 32 kilometers long, the bridge will be the longest in the nation. So I would like to take everybody to take note of the bridge aesthetics. Later on, I will present the curve alignment of the bridge to cater for its navigational constraint and connectivity, and incidentally contributing to the dynamic driving experience when you cross the bridge. Also, please pay attention to the tower architecture involving some folded stainless steel highlights and how the architecture was arrived. Also, the dynamic lighting, which will be employed on the superstructure and substructure with long-lasting LED and solar panels. So without further, on behalf of Undersecretary Emil K. Sadayan, the Build Chief Implementer in the Philippines, I would like to present the Bataan-Cavite Bridge Project. So can I share the screen?
And see, can Mr. Can you share the presenter rights with sir, please?
Yes, he has. Hello, Mr. Edwin. Yes, you can share this.
We can see your screen, sir.
Yes. So this is the Bataan-Cavite interlink bridge project, the detailed engineering design. So I would like to present with this arrangement, product introduction, detailed engineering design packages, project appreciation, challenges, and how we cope with them, and site activities ongoing now. So the project introduction. The Bataan-Cavite interlink bridge project is a ADB funded project. So the DED is by ADB funding, and later on the construction will be funded under ADB loan. The implementing agency is the Department of Public Works and Highways of the Philippines, of course. And we have the DED consultants, Lin International, in joint venture with the Pyeonghwa Engineering Consultants from Korea, and DCCD Engineering Corporation, and Rinarday SA engineers from the Philippines. So in their team, they have a team also of specialty experts, such as the boundary layer wind tunnel laboratory for wind evaluations, hydrological and scar studies, durability and plan and specifications, climate, LARP, and parcellary surveys. Excuse me. They have the structural health monitoring experts, fabrication techniques and erection methods experts. So they also have security and surveillance, and geotechnical and geophysical consultants, both onshore and offshore. So these are geotechnical studies and geophysical studies utilized in this study. Of course, topographic and nature bathymetric surveys were conducted. So Bataan-Cavite interlink bridge project, as you can see on your left, connects the provinces of Bataan and Cavite, passing over the island of Corregidor in Manila Bay, near the mouth of the Manila Bay. This is a 32.15 kilometer bridge, 4 lane with 2 lanes in each direction, with northern terminal at Bataan province, and the southern terminal will be Cavite province, here, the lower part. The project objective is to provide permanent road linkage between Bataan and Cavite, and to reduce the traffic, travel time from about 5 hours to only 30 minutes. So it will ease the traffic in Metro Manila, and the connection north to south of Manila will be provided by the interlink bridge. So this is a diagrammatic diagram of the project. The bridge will be connected to the road network in Bataan to the road networks in Cavite. Of course, connected to Manila and other provinces such as Rizal and Laguna. So this is the general alignment of the bridge. From Corregidor Island, these are the navigational channels. The southern navigational channel and the north navigational channel. From Bataan Island, we have the road embankments here. Then the viaducts approaching the main bridge at the north channel, and another viaducts and the main bridge here, about 900 meters span, cable stayed bridge, and then connected again to viaducts. Just a moment. So let me continue. So this project is divided into 7 packages: the Bataan land approach, Cavite land approach, Marine Viaduct at the north, Marine Viaduct at the south, and of course the main bridges are North Navigational Bridge and Approaches Package 5, South Navigational Bridge Package 6. So here are the main bridges, 400 pylon-to-pylon cable stay bridge at package 5 and 900-meter pylon-to-pylon at package 6. The cross-section will be like this, 2 lanes in each direction with 2.5-meter shoulder and 600-millimeter marginal strip on both sides of the median island. So this is just, we cannot read very much about the lettering, but in short, this is the general arrangement of the bridge. Bataan side here, Bataan province, marine viaduct, connected with the North Channel Bridge, then a marine viaduct with an interchange to an island here with some amenities. So viaduct again, then 900-meter long South Channel Bridge with pylon to pylon 900, then viaduct again going to Cavite. So mainly these are the bridges, the main bridges included in this project. The 900-meter South Channel Bridge and the North Channel Bridge with 400-meter main span. The marine crossings typically are consisted of series of this arrangement. So this is a single cell box girder with 70-meter exterior spans and 5 at 100-meter interior spans. You will see later on how the global modeling of these bridges is done. So these are the onshore approaches, packages P1 and P2. So these are the connection from an interchange here with land embankments probably and roads. Then on the other side will be the same with an interchange, elevated interchange actually here at the Cavite side, connecting to the existing roads. So from the Bataan shore, you will see something like this, very elegantly designed piers with these corrugations, and at the sides you will see some stainless steel highlights. From the Cavite shore, you will see something like the same single cell box girder with a single column shaft. So for the marine viaducts, which is the main portion, the longer portion of this project, P3 and P4, we have something like this. Of course, near the cable stayed bridge, we have to split the box girders into 2 columns, into two cell box girders, because the superstructure of the main bridge will be split steel boxes with cross beams. So the same motif of the columns. So the marine viaducts were separated into those with in deep water with greater than or equal to 10-meter depth of water. So we use the main spans for this 10-meter depth water with 100 meters spanning of the bridge. For the marine viaduct in shallow waters, less than 10 meters, we use 60-meter main spans. And for the nearshore navigational channel, we provided for 150-meter main span. So as you can see here, for the marine viaducts, for the 100-meter span, we use barge sections to optimize on the cost, of course, and the design. So we use a barge section from 3.6 meter to 6.2 meter at the supports for the 100-meter span, barge sections. For the 60-meter spans, we use uniform section. This facilitates the construction because majority of the spans are using 60-meter span. So this facilitates the use of formworks for the same uniform section. So the global modeling for the shallow water zones. The main span length is 60 meters, as said earlier. This will be consisted of the outer span is 45 meters, outer, and we have 8 at 60 meters.
Hello?
Span like interior spans consisting of single cell box girder. At the piers will be solid and with the seismic isolator. So all of these interior piers will have isolator bearings. This is the marine viaducts at the top. This will be elegantly bounded with a wide shoulder and concrete barrier with see-through railings for a clear view of the sea. At the corridor island connection, we will have this interchange, providing for the U-turn or change of direction of the vehicles. Of course, some amenities will be provided in the island later on for the development, some more developments for tourist attraction in this island. This is already, actually the island is already a tourist attraction because of the so many artifacts such as cannons and defense weapons during the World War II placed in this island. So this is the island, some amenities. You can maybe if we can scan this QR later on, you will see the more of the 3D of this island. Same corridor island. So for packages 5 and 6, finally we are on the cable stayed bridges at high level viaducts. So these are the navigational channel number 1 at the north and navigational channel number 2 at the south, the existing one, and a smaller navigational channel for near shore navigation. So the North Channel Bridge is the shorter of the two spans, consisting of 400-meter long cable stayed bridge on single pylon, single column pylons. This will be the split type steel box girder with cross beams, adding to its elegance. Later on you will see on the video because it appears very light. So the pylon will be like 179-meter total, and the deck will be about 80 meters from the sea level. The bottom portion will be hollow octagonal shape, while the upper portion is a more complicated section like this. But later on, you will see how this affects the aesthetic of the bridge structure. The deck for the North Channel Bridge will be simple girders with cross beams, of course, with cables on the outer ends of the transverse section. On the South Channel Bridge, the other navigational channel will provide for 900 meters, almost 1 kilometer, unsupported section, pylon to pylon. So this is adopting the same single column pylon with split deck and cross beams. So this is the North Channel Bridge global model. The split, this is the split superstructure with single monopole pylons. At the ends will be the connection to the marine viaducts. So for the South Channel Bridge, it will be this section at the bottom, going to a more complicated towards the top here. To add to its, to the elegance of the bridge, as you will see later on. For the main bridge, which is 900 meter span, the most, as per cost and design optimization is this double cell split steel box girder with cross beams. This is cross beam because this is the position of the pylon. So this is cross beam, split type, and the cross beam section will be like this, as a simple square. This is a global model of the South Channel Bridge. So you'll see the brown portion as the split steel box. So 900 meter center span with 354 and 96 outer spans. So for the high level approaches, we have these sections of, as shown before, 3.6 meter to 6.2 meter single cell box girder. For the support of the high level approaches, we have this model. So at the ends, of course, are movable bearings. At the intermediate are rigid bearings using seismic isolator bearings. So you see the pile foundations marked in red as because these are actually modeled as to behave as elastic during the entire or all levels of service of the bridge. So if you scan me in this lower right hand, you will see the 3D rendition of the bridge above the South Channel Bridge. So let me present just a small video of I'll escape this screen from PowerPoint, and I'll shift to the video. Paano natin? Ito, sa paano pupunta sa ito sa, let me see. Just a moment, this is little technical.
Sure. Sir.
Can you see the animation, the video?
No, sir, we can't see anything right now. Maybe you would have to share your screen again for the video to play as well. Yeah.
This one. How about that?
Yeah, we can see it now. Yes.
The Bataan Interlink Bridge project will transform the infrastructure landscape of the Philippines. Spanning the mouth of the world-famous Manila Bay, the project will provide a vital transportation link for the region and the nation. At 32 kilometers long, the new iconic gateway will drastically cut travel time between the provinces of Cavite and Beton from 4 to 5 hours down to only 30 minutes. The project is made up of 6 main components. On the south end, a new highway connection will link the existing roads in Cavite to the bridge. Out over the water, a low causeway structure called the Marine Viaduct carries vehicles along the majority of the bridge and leads to the first of 2 shipping channel crossings. The South Channel Crossing is an iconic cable stay bridge structure with one of the longest cable stay spans in the world. Near Corregidor Island, the bridge has an interchange which allows for turnarounds and will connect to the island as part of a future project. The North Channel Crossing spans over the second shipping channel. And Finally, back on land, the highway extends to connect to the existing roadways in Bataan province. For a detailed look into each of these project components, we return south to Cavite. Here in Nike, we see how the new highway connects to the existing Antero-Sariano Highway and heads alongside Timolan-Balsahan before passing through the new gateway entry monument at the water's edge. The marine viaduct follows a gently curving alignment that is derived from the connectivity and navigational constraints. It also creates a pleasantly dynamic driving experience. Deep marine foundations provide stability for all the piers, and the simple single-column pier design creates a clean and contemporary visual rhythm. The South Channel Crossing is one of the longest in the world with a clear main span of 900 meters, which allows the largest shipping and cruise vessels to pass underneath. For this cable-supported segment of the project, the roadway structure changes from concrete box girders of the marine viaducts to lighter steel boxes tied together with cross struts. The road deck is 80 meters above the water, and the full tower height is among the tallest in the world at 335 meters. To create a design that is uniquely Filipino, the architectural shape of the bridge towers take inspiration from their tropical setting and the symbolism of the Philippine flag. The three distinct parts of the flag reflect the left, right, and middle of the bridge towers. The 8 original provinces of the sun rays become 8 folds of steel, which are colored like the famous teal waters of the island nation. Finally, to reflect the profound sense of faith found throughout the Philippine community, the South Channel towers fold inward like praying hands. A tower design unlike any other in the world, the folded steel inlay gives the insides of the towers a textured feel reminiscent of the thatched palm roofs found on indigenous Filipino houses. This distinction from the smooth gray concrete breaks down the scale of the tower into light, thin blades. The tower tops are asymmetrically angled, and the pair of towers mirror each other, like bookends framing the channel. The architectural lighting for both cable stay structures includes 3 components: tower illumination grazing the recesses along the height of the tower, cable uplights, and approach piers lit from small downlights at superstructure level. All fixtures are durable LEDs, and the entire bridge will have fully programmable color-changing possibilities. The driver's view is the way most people will experience the bridge. This is why it was important to put the tower treatments on the inside surfaces, facing the traffic. The perspective of approaching the towers from far away, and then getting closer and closer, will reveal new details every time the light and shadow change throughout the seasons. Open steel rail barriers allow users to fully enjoy the magnificent views of the surrounding landscape. From the roadway, you can feel how the structure above envelops you, like driving through a cathedral of cables. As the middle segment of the marine viaduct nears Corregidor Island, simple off and on ramps in each direction allow drivers to change direction on the highway. A future project will connect a road from the island to this interchange. The North Channel crossing is the smaller of the 2 cable stay segments, but it is still a significantly large structure. Its main span stretches 400 meters long. Due to its differing proportions from the South Channel, the roadway deck this time is a frame system comprised of steel girders and floor beams. The deck is lifted 47 meters above the water, and the full tower height is 181 meters tall. Where the South Channel crossing was idealized around clasped hands that come together, the North Channel tower evokes uplifted hands as the central steel element opens wider as it nears the top. In this way, they both use the same visual language already established by the architectural theme, but still have their own unique identities. They are sister structures, and the rest of the components of the project make up the remaining family of forms within their theme. North Channel crossing is the same as for the South Channel. The roadway lights for the full project are long-lasting LED fixtures and may be powered by solar panels on top. Their custom-designed poles are vertical throughout the standard marine viaduct portion of the project, but at the two cable stay crossings, they angle to match the inclination of the cables. As part of the family of forms, the marine viaduct piers share a similar textured inset with a curved base to match the towers, and the twin high-level approach piers that lead up to both cable stay crossings have an extra single stripe of matching teal steel down their sides. The piers throughout the project are all comprised of precast concrete segments. As we near the end of the bridge crossing, it's nice to reflect on the journey of implementing the project. After completion of the feasibility report in 2019, the project began detailed engineering design in 2020. And with the cooperation and coordination of many government agencies, this final design phase will conclude in 2022 or early 2023. 4 to 5 years of construction will follow, bringing with it at least 3,000 new jobs, and the possible opening date for the bridge is late 2027 or early 2028. Finally, as the bridge reaches the shore in Bataan, it passes through another gateway entry monument before continuing up the hill toward Mount View, where it connects to the Roman superhighway. A project of this scale is an admirable undertaking. Thanks to the hard work of the Department of Public Works and Highways and the financial support of the Asian Development Bank, the Bataan-Cavite interlink bridge will be well worth the investment in the Manila Bay community.
Just a minute. I'm just
Sure.
going to do the presentation.
And Mr. Edwin, if I may request you, if you can keep your presentation, we have about 4-5 minutes more for your presentation because we are getting a lot of questions from the delegates. And we would like to spend some time on those questions as well.
Very quickly, and let's go back to this presentation.
We can see your screen, sir.
Yeah. So this is a very simple about the challenges that the COVID lockdown and the connectivity of the experts. Also, this is we were able to address as we are doing now. Site activities. I just want to cite, we use here instead of the ordinary geotechnical investigation, we use the geophysical in combination with geotechnical. It is used in most of the long span structures around the world. So this geophysical was used in this survey. Marine hydrodynamics was conducted, durability analysis, marine collisions analysis were done. Also, wind engineering studies were lined up for this project. Environmental studies, of course, land acquisition. Also, this one is very important. We also considered in the design of the cables and the piers to be accident and terrorist protected. We conducted regular meetings. I think that's all about my presentation. Thank you very much, Akanksha.
Thanks a lot, Mr. Edwin. It was a very interesting presentation and a very, very comprehensive one. We have a couple of questions from delegates, and if time permits, I'll also have some questions for you. We have a question from Mr. Sayyid Ehsan Hikmat. He is asking how slenderness is controlled in the design of vertical elements.
I think the slenderness of, for example, the columns and the main bridge are controlled by the aerodynamics analysis of the structure. There's the aerodynamics and seismic analysis of the structure. We have some analysis here in another presentation, but I don't know how can I explain it fully by just talking here.
All right. So,
Maybe I can share this some of my PDF in this section. They can take a look at it, how slenderness were considered.
right. Also, you can probably share it with us, and we can have it shared
Yes,
with
we have it.
the person. Yeah. So the next question is, what is the challenge that your team faced when they proposed the superstructure arrangement?
Yes, actually, in the decision for the superstructure arrangement, for example, like in the main span, we have considered single cell box girder for the steepening deck, but that will be good for diamond type pier. But now we are using the monopole pier. Therefore, the one who is which is more for that particular type of support will be the split steel boxes with cross beams. All the split steel boxes with cross beams appears more elegant as shown by our consultants. Actually, we have spent a lot of time debating this with our consultant, the designer of the towers, design of the superstructures, and its aesthetics. We have a lot of meetings here. Thank you.
So there's another question on alignment. This is a question from Mr. Sama Srinivas, and he's saying that alignment is not straight. There's no minimum length or not curved in the plan. Is there a specific reason for that?
Yes, actually for the navigational requirements that we have to comply. Also, I think we have compared several alignments and we have decided this one. And incidentally, this alignment, which is a curve in many places, will be adding to the dynamic experience of as you pass by the bridge. That's one consideration that helped us decide on this curve alignment. Thank you.
Okay. So there's another question which says that, I think in your video, there was a marine viaduct section that was designed with inclined piles. So, the delegate is saying that they are assuming that those were steel pipe piles. So, have you considered between board pipes and steel pipe pile about the constructible and costable?
Yes, we did compare about driven steel piles and concrete piles. Those were finally decided to be board piles or cast-in-place piles. The slanting portion that you are colored red in the presentation is actually the board pile foundation of the bridge, designed elastically in any stage of or any performance level of the bridge. Thank you.
So this is a broad-based question. What is the current status of construction, and what kind of a completion timeline are we looking at for this project?
Actually, it was in the presentation, but I was not able to proceed to the last part of the presentation. The timeline will be, the detailed design will be completed early next year, by January next year.
Okay.
Tentative schedule of loan negotiation will be the second quarter.
All right.
Then procurement will be second quarter to third quarter of 2023. And fourth quarter of the next year, we will start the construction. And finally, completion date will be early 2028, hopefully. Thank you very much.
And so this would be the last question. This is more on smart bridges. We heard our earlier speaker also talk about various technologies that are coming in. So if you could throw some light on those components and how they are going to be, become, how you will make them a part of this Bataan-Cavite.
We do have this dynamic lighting in some of our bridges here in the Philippines. And there's for this Bataan-Cavite, we are going to employ the same dynamic lighting. Okay. So it's will be computerized computer control. I think smart control. I don't know. I'm not a specialist with IT. I'm sorry.
And will you be also exploring the structured health monitoring systems that are now, gaining traction?
Of course, we will require them to submit the maintenance manual. In
Right.
all our bridges, we do require
Right.
our consultants to prepare. Also, all contractors are required to submit upon completion of the project.
Mhm. All right. Thank you very much, Mr. Edwin. I'm sure all our delegates would agree that it was a very, very informative session. And thank you so very much for your time and for being here with us today to give this presentation. And all the very best to you for the construction of this bridge. Thank you so much for being here.
Thank you so much, Kansha.
With that, we are now ready to begin the next session for the day, which is on underdeck access and netted safety solutions for bridge construction and repair. For that, we have Mr. Mark McConvey and Mr. Francois Botha from Web Systems International with us here.
Good afternoon, everyone, and welcome to a short webinar on underdeck access and netted safety solutions for bridge construction and repair. Just before I begin on that, I wanted to congratulate Mr. Edwin on a very interesting seminar and also on the imaginative design of the bridge. So congratulations on that. As you've said, Francois will join me to answer the questions. So I get the easy part of the presentation and he gets the hard end. So with that, I'll just begin.
Mr. McConvey, if I may interrupt you, I'll just spend 30 seconds in introducing you and Mr. Botha for our delegates here. So yeah, just 30-35 seconds. And then you can, of course, go ahead with your presentation. So very quickly, Mr. McConvey is Managing Director of Web Systems International, the Scottish Indian innovators in underdeck access platforms and protective netting solutions. He has spent most of his career developing innovation in a variety of industry sectors, but mainly construction. He also won the John Logie Bayard Award for Innovation for developing the first variable height security counter for wheelchair using customers of banks and rail stations. Mr. Mark graduated with a first-class honors in business. And as he rightly pointed out, he is joined by his colleague, Mr. Botha, today, who is Technical Director, Web Systems International. He comes with over 20 years of rope access experience, both as operative and industrial rope access instructor. He's worked internationally in various industry sectors, providing supervision, training, management, and consultancy, all relating to work at height and industrial rope access. In 2015, he was appointed as an IRA-TA assessor and has since served on industry-related training and equipment and standard committees. Mr. McConvey, Mr. Botha, welcome. And Mr. McConvey, you can now go ahead with the presentation.
Thank you very much. So to put it into perspective, this seminar we hope will be useful to anyone who's involved in building bridges, maintaining bridges, engineers who are planning bridges and particularly planning access to the underside of bridges, scaffolding and rope access companies who we deal with a lot across the world, and indeed health and safety professionals. So hopefully we have something for everyone in relation to the webinar. There are basically two things that we would like to talk to you about today. The first of these is improving safety and increasing productivity using new technologies for people when they're working at height. In particular, we want to introduce WebDeck and WebNet, which are two proprietary products of Web Systems International. And the second area, which is of great importance, is how we would go about protecting people and assets from the risk of dropped objects. Now, this could be during the construction of a bridge, whilst the bridge is being maintained, and also as a preventive measure on older structures to prevent spalling or debris coming down on people below. So in order to understand the new methods, it's probably an idea for us to consider the traditional methods of access to areas where people will be working at height. So mainly for obviously many years, scaffolding and towers have been used in this context. And there are great advantages, obviously, for using scaffolding. The main ones are that it's universally understood. It's readily available in most parts of the world. It involves standard components, and there's a large pool of skilled labor to install scaffolding. However, in certain situations, it can have disadvantages. So the main ones include the fact that scaffolding is a ground up, or most of the time is a ground upwards technology. It can be slow to install over large areas, and in many situations where there are roads required to operate below, the scaffolding can cause obstruction. When used as a suspended system, some scaffolds can impose significant loads on the structures, and it can present greater risk to safety than some of the more modern alternatives. If I digress slightly for a moment, but to set things in context, yesterday I was reading a statistic from the World Health Organization about the overall statistics on falls around the world. And believe it or not, 684,000 people are killed around the world from falling. And many of these are preventable in the construction industry. And this is something that we are hoping to assist with some of our systems that we're about to demonstrate. So the new methods of access I've referred to as a blended method, in the sense that it combines some of the traditional techniques involving scaffolding and some of the more modern access techniques such as rope access. And then we look at our suspended decking system, WebDeck. Now, as you can see briefly on this photograph, we've shown a combination of a scaffold tower and also WebDeck in an installation. The advantage of using WebDeck is that it uses the safest techniques for installation. So in other words, we're using fully trained rope access technicians for the installation of the anchor points on either side. Then once the anchor points have been installed and the catenary wires are in place, the decks can be deployed over large areas very quickly. Another advantage is that WebDeck leaves fewer contact points for retouching. So obviously scaffolding has many contact points. A WebDeck system has fewer. As I was saying before about loading on the structure, this is a very lightweight system. So it imposes much less load on the individual structures. If there are disadvantages in relation to WebDeck, it's simply that it's less well known than scaffolding is around the world. And over the last few years, we've been developing a network of installation partners. So more and more people are learning of the advantages of using a WebDeck system. The other slight disadvantage at the moment is that installation of part of it requires trained rope access teams. So rope access as a profession is not yet well established in all countries. It's certainly getting there, and hopefully over time that will improve. Very briefly, the systems that are available from Web. We have WebDeck, which is the catenary wire suspended decking system, which can also be provided using our truss system as well. We have WebNet, which is a specifically designed work positioning netting system, and WebCatch is our dropped object protection system. So these are the three main systems that I'll be talking a little bit more about in the course of my presentation. But just to say that in addition to that, we also have our own design, engineering and training capabilities. So moving firstly to WebDeck, you'd be interested to know what WebDeck is. And we've described it as an innovative suspended decking system. And as you can see from this photograph, WebDeck has been installed below a bridge. Once it's in place on the catenary wires, it's then further supported by pickup chains along its length. And all of these have been worked out in advance by our engineer. The individual solid decks are available with a ply surface, an aluminium checker plate, and modern composites that will take loads up to 2.5 kilonewtons per square meter. The majority of the installations that we're doing at the moment, we're using aluminium checker plate surfaces. And in addition to the solid deck, we also have a grated deck that is used in situations where you may have tidal influences. And I've got a very short video just to show the deck in place. So you can see from that in these situations, the deck has been designed to allow water to flush up through it and then wash away. And as it does so, the grating provides a very good anti-slip protection. I'd just like to mention that this particular location that we're looking at, this was actually a jetty rather than a bridge. But the important thing to mention is that we provided about 5,000 square meters of decking for that project. So WebDeck can be used effectively on very large areas as well. The type of work that can be undertaken from a WebDeck system includes light work such as inspection, cleaning, but it also goes on to some of the heavier activities from blasting and painting or corrosion protection and concrete repairs. So this system can be used very effectively if you have heavy machinery to bring on to be used on the underside of a bridge. This is just a very short case study of a remote rail bridge that we were recently asked to do an installation of WebDeck on this rail bridge in India. So to explain, first of all, what the issue was, so basically access to the underside of the bridge was required for necessary routine inspections, and it needed a fast to install solution also for maintenance and repair. And the refurbishment work had to be carried out on the structure whilst keeping the limited load-bearing capacity in consideration. And you'll see on the next slide that this was done very successfully using a WebDeck system. In fact, on the bottom photograph, you can see the first of the WebDecks being placed on the catenary wires, and then in the photograph above that, you can see subsequent decks starting to be installed. And the other thing that you can't see from the photograph is that anchors were installed on either end of the bridge, and this was done using rope access techniques to accommodate the main catenary wires. And here we can see the results. So a safe and reliable solution was produced. It should also be mentioned that this was also very cost effective. And on one particular section of 6 meter wide by 30 meter long, the installation time took just under 4 productive shifts, and it was removed in 3 shifts. So I guess the main thing that we're focused on is reducing the number of hours that people are exposed to the risks associated with working at height. So particularly in the UK, there's been a statistical focus on reducing the number of hours worked at height to subsequently reduce the number of death and injuries resulting from people falling from height. And it should be mentioned that in the construction industry, falls from height are still the biggest single cause of deaths on building sites. I have a very short video here showing you WebDeck being installed, and it gives a very effective view of how this can be used to assist in accessing the underside of bridges in particular. The specification details that I think may be of interest at this stage include the fact that our system is lightweight. It comes in at 20 kilograms per square meter, and it can accommodate various loading capacities from 0.5 kilonewton per square meter through to 2.5 kilonewtons per square meter. The decks come in 3 lengths. We have a 1 meter deck, a 2 meter deck, and a 3 meter deck, but the width is kept constant at 600 millimeters. Now, the reason for this is that it allows for very effective manual handling, particularly in confined spaces. As I've said before, the system offers a low number of contact points, and it comes with either an aluminium checker plate or the grated flooring surfaces. What we're looking at here is a very typical WebDeck arrangement, and we've shown on the schematic how one set of anchors can be put in place, and then the catenary wires are laid out between the anchors and then followed up with the pickup chains. So in this particular diagram, the pickups also use beam clamps to secure the chains, but that can be accommodated in other ways. So this is just an illustration rather than something that is used in every situation. So what normally happens is that we would look at an individual project, assess it from photographs and drawings, and then our engineer and design team would put together the appropriate design, taking into account all of the considerations that may be required. WebNet is our proprietary tension netting system. And the reason why I wanted to spend just a minute on this was to distinguish it from other systems that you may have seen in the past that use fall arrest nets that have been modified to allow people to walk on. WebNet is designed specifically to reduce the amount of deflection on the net when someone is walking on it. So there's no walk-on netting that is exactly comparable to a web net system. So in certain situations where there might be light works required, web net can be a very effective way of accommodating that. Moving on to dropped object protection in relation to bridges. Now, obviously, the dropped objects can occur for a variety of reasons. One of these can be spalling from concrete bridges or debris that's been left behind when contractors have been working below the bridges. So this is a very short case study to show how this was accommodated using a web catch system. So this was a bridge in Scotland over a very busy road and railway. And if I just show you the next photograph, it's the same bridge, it's just a close-up. And you can see that it also had a street below and a railway running next to it. So we were asked if we could accommodate this with a web catch system. And I should mention that web catch is not one singular netting system. It's a combination of our proprietary netting systems that are used either on their own or together to provide the best solution for protection against dropped objects. And you can see here that the web catch system was used to fully encapsulate the bridge so that nothing from the smallest item to the largest, nothing could fall through the netting system. And to further demonstrate just how strong and effective our web catch system is, I'd like to just show you another short video, which lasts about just under 2 minutes. So I'm hoping that having seen both of these systems, you can see how they can be applied to particularly bridge projects. And just to conclude with a couple of slides, you can see that the web catch system is also very useful for protecting or keeping roads flowing in these situations. That now some of the bridges that we've been involved with have been involved in large scale manufacturing plants, etc. So the bridges can be in unique locations and can benefit from both WebDeck and WebCatch systems. And finally, this is just a brief montage of our capabilities so that you can see, in addition to using WebDeck on large bridge projects, it's also been used very successfully in offshore situations, in oil rigs, also in jetties and in high-rise construction. Web Systems International has been involved in using our award-winning WebDeck in situations around the world. And for the Australasian market, we feel it's also important to note that we are now manufacturing our systems in India. So for being able to get to jobs around the world, this reduces lead times and has helped us be far more competitive in the Australasian market. So that concludes the formal part of my presentation. And I would like to hand over to Francois to answer any questions that people may have on the presentation.
Thank you so much, Mr. McConvey, for a wonderful presentation. I'm sure it was very interesting for all our delegates to know more about your solutions. I have a couple of questions for Mr. Botha. So, to begin with, how do people get on to this WebDeck system once it is installed? Is there a staircase, or how do they go about it?
Yes, we'll either, when we do this initial design, we will design either a scaffold staircase that goes down, or a ladder, or a staircase that goes up to it. It really just depends on the challenges it faces on site, and what the conditions are and the client requirements.
And once they're up there, do they still remain to be clipped on, or wear a harness?
The system is engineered as temporary access, and it comes with, in essence, yes, to your question, it comes with two fall prevention options. One is a low deflection net, netting system like behind me, and the other one is a rigid handrail. And once again, it depends on client requirements, local legislation. Traditionally, the site containment net is our go-to choice. It really is assists with also fall prevention, but also for encapsulation or containment, depending on the type of work that needs to be done.
And so how frequently do these installations need to be inspected? I mean, at what intervals?
That also depends on legislation, but we would recommend at least once every 7 days have an inspection regime. It will also depend on your risk assessment and post if there's any changes made to the system, or if there was any adverse weather that exceeds the minimum design calculations. So in all these instances, we would recommend an inspection, but usually every 7 days is the minimum requirement here in the UK anyway, for any temporary access platform.
Okay. And do you also provide training to the people who are working on this?
Yes, we provide different type of training. We've got trainer programs for what we like to call approved installer partners. And then we also have training directly to the client, our clients. It just really depends on their requirements and if they want to install the system themselves or subcontract the installation to a third party.
And are these components of the web system reusable?
Yes. Most of the components are interchangeable, interusable from one project to the next project. Most of the component parts are standard in size, so they can be used from one project to the next project in different systems. So as Mark was saying, we've got a mega truss or a truss system and a catenary system. The decks come in standard sizes. They work on any one of these two systems. And the system that we would recommend would once again be dictated by challenges faced by clients on site.
Right. And so what kind of selling model are you following right now? Are these also available for rent, or you just sell them?
Yes, we do both. We've got a sale option or a rental option. through a network of distributors in various regions. Where we don't have distributors in the region, you're welcome to just contact us direct, and we would approach it in that fashion.
Right. And Mr. Botha, my last question would be, how has been your experience in the Asian region, in terms of demand for such products or such systems?
The demand is on the rise. Obviously, we come out of a global pandemic, but the demand has increased, and I guess the demand will still further increase, because not only the amount of bridges that's getting built or planned to getting built, but the amount of bridges that's in disrepair or globally at this moment in time. There's a vast amount of maintenance and repair and refurbishment that needs to take place. Here in the UK, we've got a CDM regulation that places onus on future maintenance regimes on structures. And that's coming in effect now, where at the engineering or the design stage of any structure, future maintenance has to be considered. Even though I know a lot of the bridges and structures get designed to have a lifetime of 20 years or 30 years, but within it's easily viable for within 2-3 years in a harsh environment for maintenance to be, or at least routine maintenance to be done on all these structures.
All right. Thank you, Mr. Botha.
Thank
That
you.
was very informative. In fact, I would like to extend my thanks to Mr. McConway too, for taking out time and being here with us today, and also for sponsoring our conference. With that, we've come to the close of this session, and we will now be taking a short break. So this is an information for all the delegates here. We will be now breaking, for a lunch break or a tea, coffee break. And we will resume the first day of this conference in next 30 minutes. So by Singapore time, we will be resuming the sessions at 1:30 p.m. And as per the Indian Standard Time, we will be resuming these sessions at 11 a.m. I would like to request, thank you, Mr. Botha. I would like to request all the delegates to please come back on time, as we do plan to resume the sessions at 1:30 p.m. SGT and 11 a.m. IST.
We would be beginning in the next 2 minutes.
اسم الشتاء عندنا تنوص من طلع
Welcome back, everyone, to the conference on bridge construction in Asia. I'm Ishita, and I'll be moderating the next few sessions. We're ready for the next session, which is Project Showcase Chenab Railway Bridge Construction, which will be a presentation by Mr. Srinivasa Mantrala, Vice President, Technical Afcons Infrastructure. But before we begin with his presentation, I'll quickly introduce him for the benefit of the delegates. Mr. Srinivasa Mantrala has 36 years of experience, including 11 years in the design, construction, and knowledge management of the iconic Chenab Bridge, which will be world's highest railway bridge once completed. He is currently involved in the construction, planning, and engineering of 2 cable-stayed bridges on the Mumbai-Pune Expressway and an extra-dosed bridge for Ahmedabad Metro. His areas of interest are training, knowledge management, innovation, and applications of artificial intelligence and civil engineering. Mr. Srinivasa is a graduate in civil engineering from NIT Warangal, postgraduate in marine geotechnical engineering from IIT Madras. Mr. Srinivasa, we are ready for you. So it's going to be a 20-25 minutes presentation followed by 5 minutes of Q&A. You can share your screen, sir.
Okay, thank you. Thanks for your nice introduction. Can you see my screen?
Yes, it's visible. Yes.
Okay.
Perfect, yeah.
Good morning and good afternoon, friends. I'll be taking you through Chenab Bridge project, which is India's pride. And this is how the bridge looked a couple of weeks back. I will show you the latest photographs sometime later in the presentation. This will be world's highest railway bridge and as a part of Udhampur Srinagar Baramulla rail link project. And the bridge is situated in Himalayas, where the Himalaya mountains are young and active. So there are a lot of earthquakes in that area. So the bridge needs to be designed very carefully for seismic forces. Temperatures goes to sub-zero, and it has sensitive border area, and more important, it is difficult to access. So we have built this bridge in this most difficult terrain, and while the bridge is the real thing which you all can see, but the spirit behind the bridge is the newer technologies and innovations we brought in this project. So I would like you to give you a brief introduction of Chenab Bridge, followed by some of the key challenges we handled and what we achieved in terms of safety and quality, and what is the last challenge left on hand, and then I'll conclude my presentation. So brief introduction, the project is owned by Northern Railway, and Konkan Railway is some sort of project management consultant for this project. And contractor is a joint venture of Ultra, Afcons, and BSL. And then the design consultant is WSP Finland and Leonhard Andra and Partners from Germany. And proof consultant is currently AECOM and COVI. For slope stabilization, which is a major chunk of the project, for which we have purely Indian consultants, IISc Bangalore and IIT Delhi. I'm very happy to inform you all for this gigantic engineering project. Entire construction engineering is done by Afcons in-house. The project is located around 125 kilometers from Jammu, and the 40-feet trailers can go up to around 75 kilometers from to Jammu, and for 50 kilometers they cannot fly. So we required a transshipment location at the site, and this posed severe logistic management issue. So this is the general arrangement of the bridge. So the height of the bridge is around 362 meters above the bed level. Just to get a feel of it, you can put Eiffel Tower below the bridge and still you have 20 to 25 meter clearance. And if you look at the plan view of the bridge is predominantly straight. And on the viaduct side, you have transition curve followed by a circular curve. And if you have a little more detailed view in terms of structural arrangement, the deck is continuous for the entire arch portion of 785 meters and 530 meters on the viaduct portion. This arrangement necessitated use of special rail and expansion bearings joints for this bridge. These are the main highlights of the Chenab bridge. A project of this nature cannot be done with simple things. This is the world's highest railway bridge with a design life of 120 years. And we have done incremental launching of deck on combined circular and transition curve for the first time in the world. And we also deployed world's largest capacity crossbar cable crane for the erection of piers, trestles, and arch segments. Since the bridge is in a hilly terrain across a valley, extensive wind tunnel testing is carried out in Force Technology Lab in Denmark. And this is such a extensive studies were taken up for the first time in India. This is the first bridge which has been designed extensively based on the principles of fatigue, design and detailing based on BS 5400 Part 10. And this is the first bridge in India where we have used double corrosion protected bar and cable anchors which have a life of 120 years. And we have used the largest possible HSFG bolts of M36 diameter of 10.9 grade with geomet coating. And the bridge is designed against blast loads. And special considerations are geographical location, temperatures go below 0. So we adopted special structural steel, seismically active area. So we have developed site-specific response spectrum for the site and used it in the design. And we have carried out dynamic analysis of the structure and designed accordingly. And we also have done the ductile detailing. And geologically, the strata is very erratic. So we have done extensive geotechnical and geological investigations. And we have done extensive slope stability analysis. There is a possibility of high winds. So there is a provision of instrumentation to stop the trains when wind speeds exceed 90 km/h. And we have designed the bridge based on wind tunnel tests. Sensitive border area, yes. So even if you remove one pier, the bridge will not collapse under its weight. And also, even if you remove one member of the arch, the bridge will not collapse. Still, you can carry the loads. And similarly, even if you remove one diagonal member of the
Mr. Mantrala, you're on mute, sir.
So we also lost your presentation.
Okay. Now, can you hear me?
You're audible, but could you also share your screen? We lost your presentation.
So you had up to this or up to this?
So we can't see your presentation. You would have to share the screen again with the audience.
One minute.
Yeah.
Can you see the screen?
Yes, it's visible.
So you could see this special considerations in design, this part.
Yes.
So even if you remove one diagonal member, the bridge will not collapse and you will be able to carry the paints. Now let me take you through the challenges handled systematically. To start with is logistics management. So one is, as I told you, 40 feet trailers can go up to a place called Riyasit, which is a district headquarters. So we set up a transshipment area. Then we have designed components that can be transported with little difficulty. We have split the length of the members and we have coordinated with the local authorities for widening of the road. And we made elaborate arrangements for lifting and shifting arrangements at site. So I need a member which is 19.2 meter long that has been split into two parts for ease of transportation. This is a design management part. This is how the roads look like. And if something falls, it falls about 500 meters deep into a valley. So it should be very carefully done. And this is another view of the roads. So what we did was we made a mock-up of the maximum size of the component we are going to ship. And then identified the locations and requested the Border Roads Organization and Jammu Kashmir WD to widen these roads so that we can move our components. So after all the widening, this is how our trucks are plying. This is how the components are being moved. When it comes to heavy lifting and shifting arrangements, if you see, this is where we have to shift something like 120 ton base segment up by around 38 meters. So this is another view. So I'll show you the animation. This segment, which is around 120 tons, we are lifting with the help of a crane and place it in position, and then we'll shift locally with the help of jacks. So all these arrangements are done at site given the access constraints and space constraints. Then we have done incremental launching on combined circular and transition curve. This is done for the first time. Normally, incremental launching is done either on a straight or curve of uniform radius. So we have done an innovative solution. We developed what is called a uniform launching circular curve, and the bridge deck, which is prepared as per the actual transition curve and circular curve, is launched along a hypothetical launching circular curve. One of the key requirements was the dimension X here and the dimension Y should be the same. And in the process of launching, the deck will move from one side to the other. And for that, we have used a special wide wide bearings, launching bearings. And we also use the central guidance to ensure that the deck moves as per the desired launching curve. And this is how the finished bridge looks like when it is done. And the bridge is done, launching is done in two parts. First part, that is with the circular and transition curve from one side and straight portion from the other side. And when these two joints, two sides come and meet at the center, the accuracy required, tolerance required is barely 3 millimeters. And I'm very happy to say that is the level of tolerance we achieved in our execution of the work. Then another major challenge in this project is slope stabilization. Like I was mentioning, since the strata is varying, we have analyzed by different approaches, treating it as a soil, treating it as a rock, and it is designed for static conditions, pseudostatic conditions, and dynamic conditions analyzed, and finally designed but the designs are governed by wedge failure analysis. And we have, for ease and quickness of work, we use steel fiber reinforced shotcrete, and we use passive rock bolts of different length, and we use active double corrosion protected bar and cable anchors. These are with a life of 120 years. They are used for first time in the India. So this is how the slope was looking before we started the work, and people were thinking whether it is possible, whether anybody can put foot on the other side. So this is how it was in 2012 or 13, and this is how we have done the complete excavation. The depth of excavation is more than 215 meters, and excavation is something like 6.3 lakh cubic meters of excavation, and there is shotcreting of 54,000 square meters and 33 kilometers of rock bolting. A huge quantity of work, and this has been done without a single untoward incident. And how this has been done? We made very approach roads at different levels in a very systematic way. You can see initial stages and final stages. And I'm very proud to say here, we had two excellent engineers, one Mr. Tagore and Mr. Pai, who are familiar with the even operation of the excavator. They used to walk in front of the excavator, and then they used to guide the operator how to develop these approach roads. But for these approach roads, the work would not have been done. And we followed what is called top-down method of excavation and stabilization following contours. This has been done very systematically. As you see, as you are following contours and moving, the green portion is completed, violet portion is the front available for work. So like this, we completed the whole work in absolutely safe manner. And this is how the left bank looks like, and this is how the right bank looks like. And these are the blocks, what you see. These are all the precious cable anchors and bar anchors. Then, for the construction of this bridge, we deployed world's largest crossbar cable crane. This will have two crossbars, one crossbar and another crossbar. Each has a capacity of 20 tons. And if you put a central crossbar, it will have a capacity of 34 tons. So, since we want to work everything within 34 tons, all components of arch and pier have been designed so that the weight is less than 34 tons. And there are total 1,375 components in the arch. So now, the cable crane installation itself became a big project. One is, this cable crane height is something like 128 meters. Then how to put the ropes on the top of the cable crane. So there is a movie called Cliffhanger, which came sometime in 91, 92 by Sylvester Stallone. So we used something where he is climbing the cliffs. We followed same principle. So we developed what is called, this portion is called a climbing crane. And this pylon for cable crane is erected up to 50 meters with the help of a tower crane. Then this climbing crane will assemble one module of the pylon and hold it and then move up. You see here, there is no module here. Then if you see, it installed the second module and then moved up. So like this, entire pylon construction is completed. Now after pylon is completed, I have to put the threads on the top, ropes on the top of the pylon, and which have to go from one end of the bridge to the other bridge, other side. So So the distance between these two pylons, this one and this pylon, is something like 930 meters. And how to put the ropes on the top of it? So today, if you ask, people will say, we'll use helicopter. No, that's what we see, some sort of animated things coming up in WhatsApp messages. But we have not used anything like that. We have gone for a very simple technique. We have taken two steel balloons and connected them to winches and dropped them into river from both sides. So the balls are floating, and somebody went with a boat into and collected both the balls from both sides and connected them. Then you have one single rope from one end to the other end of the bridge. Then using 12 mm rope connected to 18 mm rope to 36, 36 to 58, we lifted, the cable has been shifted from one side to the other, and we are able to put it in position with the help of climbing cranes which are already in position. So these cables have been anchored to the massive anchorages constructed at the site. So this is the finished or commissioned cable crane at the site. This was commissioned in July 2013. I will show you a beautiful photograph of this project. I call this as a jewel in reinforcement. If you look at it, each bar is of different length. Each bar is in all the directions, they are of different length. So, and if you see carefully, the whole height of this arch base is cast in 4 different stages of concrete. So, reinforcement provision, tying the reinforcement is a very, very intricate job. So that's why I call it jewel in reinforcement. And now, apart from this, in the arch base, there are Davidite bars which needs to connect the arch. These are location of this arch base is very, very important. Otherwise, tomorrow there will be error in the arch construction itself. And this Davidite bars cannot stand on their own, so they need stools for supporting them at 2 different levels of concrete which are cast at 2 different dates. So we developed a platform, we developed staging for holding these Davidite bars, and then we made sure that these stools will not fall with the reinforcement. How do we understand whether this reinforcement is falling and how to execute the work? We went by what is called Tekla software and modeled entire reinforcement, Davidite bars, tools to understand the whole process of reinforcement and tying the reinforcement. Now, the point is, my engineers understood how to do the work. Now, we have to teach the labor how to do the work. So for that purpose, we made mock-ups at site. If you see mock-ups, they are with the different color bars. Bars have been color-coded: red, white, green, and blue. So this is how the workmen have been trained to do the arch base reinforcement. And all the bars have been numbered and they have been lifted one by the other, and then that is how the work has been done. Then safety and quality, yes, this is the single point agenda for this project. So safety, if you look at it, people are working at 362 meters above water level. So people should have secure and stable working platforms, and we should not allow people to work under adverse weather conditions. So we have set up anemometers. So when wind speeds exceeds more than 20 meters per second, we'll stop the work and we'll ask all the workers to come down. And also we trained all the workmen who are working at height above 50 meters, and they have been medically checked, and only those who are found fit are allowed to work at heights. And for the safety of the people, we have provided a fixed lifeline to which they anchor their safety harness. Even by any chance if they fall, this safety harness will hold them in place. So this is how things look like. A person working at height, and these are the working platforms, and these are all the safety nets. The most important is each working platform is provided with a safety tag. If this green tag is not there, the laborer will not step onto this platform. This is how the whole discipline of safety has been enforced. And at the end of the day, Safety Council of India has given us Ati Vishisht Suraksha Puraskar. Normally, they give Vishisht Suraksha Puraskar, but looking at the safety challenges in the site and the amount of work done by Afcons and the achievement, they gave what is called Ati Vishishta. I mean, it is superior to Vishishta. Gave this award. And quality, yeah, you look at this most complicated joint which has been done in the air. And I'm very proud to say that not even a single hole in this project has been re-drilled. And all homework has been done in advance by way of mock-ups, by way of trial assembly and planning. This is another thing where the diagonal wind bracings of the arch come and meet. And okay, when I showed you these two photographs earlier, they only talk qualitatively what is the work done. Now I'll show you what is quantitatively, what is the quality achieved. This is the pier of S40, with a height of 145 meters. And we are permitted to deviate 100 mm in any direction. But after the pier is erected, on the top of it, when we took the readings, we have not crossed more than 23 mm. These figures speak the quality of work in terms of fabrication and erection. So,
Mr. Mantrala, sorry for the interruption, but sir, just 5 more minutes for the.
Yeah, I will not take more than that.
Okay, thank you.
And this is the arch, and whereas where we have got 100 mm clearance or tolerance, we have not crossed more than 39 mm. These figures speak for the quality of work done by Afcons, and that was possible because from the very best module itself, we went with highest quality consciousness. We ensured that. So we wanted to, the arch-based survey points are measured at 12 different points, and all the points we tried to ensure a minimum deviation of less than 5 millimeters. Out of 4 arch bases, only 3 have been done like that. One, only at few places, there is an error of less than 5 mm, but that did not make any difference. I showed these things just to show the commitment of Afcons for quality. And what is the challenge left on hand is incremental launching on the arch from both sides. Why this is a challenge? Normally, when we do incremental launching, it is done where the piers are on ground, on rigid supports. But here we are doing the work on elastic supports where camber control during fabrication and is very, very important. And this is the photograph of this project today morning, and this is where we are. And I'm happy to tell you that by middle of July, we'll be completing this bridge, and then that is how we converted all our challenges into a marvel. Thanks for your time. Thank you.
Thanks a lot, Mr. Mantrala. It was a very comprehensive presentation. We have a couple of questions for you, sir, from the delegates. I will just read out some of them. The first question is from Mr. Neil Banerjee. He is actually regional director with AECOM and will be presenting next on the Brahmaputra bridge. So his question is, what is the disposal plan for excavated earth?
Yeah, we have procured land for like what we call it a dump yard.
Mm-hmm.
We have procured land for dumping this excavated earth.
Okay.
So these elaborate access roads have been developed for the taking out the excavated material to the dump yard.
Okay. Sir, there's another question from Mr. Sayyid Ehsan Hikmat. His question is how the heat of hydration is being controlled and what is the parameter considered for thickness of each lift?
Heat of hydration was not an issue because the thickness of concrete pouring is always less than 1.5 meter.
And what is the parameter considered for thickness of each lift?
1.5 meter.
1.5 meters. Okay. So there's another question from Mr. Arindam Mondal. His question is, does it require in strong back arrangement? Okay, basically a strong back arrangement is required where the arc segments meet together.
No, not required. But for the arch is constructed with what is called balanced with the cantilever method of construction.
Right.
Where the backstairs have been anchored into the foundations of the other foundations in the slopes.
And so how was your experience with the incremental launching technique? Do you plan to use it in your future projects as well?
Yes, but whenever the need arises, we'll do it.
All right. Okay. And sir, I think I skipped this, but you did mention that the construction bit is going to be complete by July. So when, what kind of a timeline are we looking at for operations of this bridge?
Bridge is only one part of the total project.
Right.
And there are some more bridges in the front, like Anjikad, which is again one of the very, I can say first of its kind bridge in India. It is cable stayed bridge for railway application.
Okay.
It is getting ready. I think it will be ready by end of December.
Okay.
So, all these things have to be completed, then only trains can come.
Right.
We are slightly moving ahead.
Right. So there's another question from Mr. Sama Srinivas. He's asking what are the methods used to stabilize subsoil on embankments?
No, there's no embankment. This is all cutting. So we have used rock bolts, shotcrete, and blisters and rock anchors to use it.
Okay. And there's another question on type of bearings used in the bridge.
We have used spherical knuckle bearings.
Oh. All right, sir. I think with that, we're going to close this session. There are a lot of questions still coming in. Maybe they will come in a while. So what we can probably do is have them compiled and, share it with you. And at your own convenience, you can share your responses with us, which we can then circulate with. Okay, there's one last thing, sir. Maybe we can take this. This is a question from Mr. Devashish Bandyopadhyay. And his question is, what are the structural health monitoring aspect of this very significant bridge?
The structural health monitoring, yes, we are doing it. And we are putting accelerometers in the foundation. And we are putting strain gauges and inclinometers for the tilt of the piers and strain gauges in the arch and also accelerometers in the arch to measure the frequencies, agent frequencies.
Okay. And so this...
And we are also putting a weather, I don't say what I say, is weather station to restrict the movement of trains on the bridge. When wind speed exceeds more than 25 meters per second or 90 kmph,
right,
it will connect to signals and then trains will stop.
And so this is going to be the last question for the session. There's just one more. I don't want to leave it. It is by Mr. Norman, and he is asking what is the deepest ground soil anchor at the base at the main support?
Huh?
What is the deepest ground soil anchor at the base of the main support?
We went almost 44 meters.
Okay, okay, okay. All right, sir. I'm sure all the delegates will agree. It was a very informative, at the same time, very, very interactive session. Thank you so much, Mr. Mantrala, for your time and for being here with us today and, presenting Afcon's views. Thanks a lot. Thank you very much.
Thank you, Ms. Ishtar. Bye. Ishtar Akanksha.
Yeah, all right. Thank you. Thank you, sir.
Thank you. Bye.
Yeah, bye-bye, sir. We are now ready to begin with the next session, which is on innovations adapted in the long 19.3 kilometer long Brahmaputra bridge. And we already have Mr. Neil Banerjee from AECOM here with us, who will be presenting in this session. Okay. Sir, I'll quickly introduce you and you can put your presentation on the slideshow mode till then. As I said, Mr. Neil Banerjee is Regional Director for Bridge and Heavy Infrastructure East and Northeast India at AECOM. He comes with 28 years of professional experience in handling major infrastructure projects involving detailed design of bridges, flyovers, underground construction of metros, and is responsible for setting up operations of AECOM in Eastern India. Mr. Banerjee also has been involved in project management, authorities engineer of Dhubri-Fulbari project. Other important projects that he's worked on include metro projects in 4 cities in India, namely New Delhi, Mumbai, Kolkata, and Patna, as well as projects in international domains like Riyadh Metro, Singapore Metro, and Jakarta Metro. Mr. Banerjee is a chartered civil engineer with a postgraduate in structures. Welcome, Mr. Banerjee.
Thank you very much, Akanksha. Am I audible and is my screen visible?
Yes, sir, you're audible and we can see your screen.
Okay.
Sir, before you begin, I would just make a small announcement for all our delegates. May I request everybody to please start sending your questions while the session is in progress, because that way, we can have more number of questions and Mr. Banerjee can give detailed responses to the same. Mr. Banerjee, over to you, sir.
Thank you very much. Okay, before I start, I just want to congratulate Mr. Srinivas. My ex-boss, Mr. Giridhar, used to counsel me about this bridge. I had heard great stories from him. Yes, Chenab bridge is truly a challenging bridge. Thank you, Mr. Srinivas, for the wonderful presentation. Now from the tallest in India to the longest in India. This is from the northern India to northeast India, a place tucked away in Assam. That's a bridge connecting 2 states between Assam and Meghalaya. So what I would discuss here is how we have adapted our international expertise or international experience in choosing the span configuration of this bridge. This bridge is in progress. It's being constructed by Larsen & Toubro and AECOM in association with Pedeco. We are project management consultants on behalf of NHIDCL. We had the unique opportunity of designing the bridge as well. So this is whatever we are sharing now is based on our experience during the design stage, which lasted between 2015 and 2018. So, just a second. Sure why. Yeah. So the bridge is called Dhubri-Fulbari Bridge. Geographically, Dhubri is on the is a plain is a district town in the lower Assam, and Fulbari is a small town in Meghalaya, which is separated by Brahmaputra. Just to give you a background of the length of the bridge, the length of the bridge is something that during the inception stage, when we first visited the bridge, we were talking to the local people about the facilities here and stuff like that. Then somebody said that if there is a patient in Fulbari who is very serious, if there is a medical emergency in Fulbari, I asked them, how do you bring them to Dhubri? They said that we bring them through boats, which take 4 hours, and if the patient is very serious, then we don't go for that expenditure. We just allow that person to lay there in Fulbari. So that was extremely shocking, being an engineer who has been who is working for a multinational company and who has been born and brought up in India. It was extremely shocking to see what has the current state of affairs in our country. However, I felt proud that this 20-kilometer bridge would actually help the people to navigate from one point to other in less than 20 minutes. So, being such a big river, we had to have something, because most of the people, when we started the bridge, they said that it's impossible to build. And we had to think out of the box to see how we can actually make the construction easy. So this is the project features. It's as they say, 19.282 kilometers. This is the longest river bridge plan in India as of now. Number of lanes are, it was actually planned for 4 lanes. However, we decided that that it's not worth it to have a 4-lane. If one is building a bridge of 19 kilometers, we might as well have 2 more lanes. Since it was not required as per the traffic demand, so what we had done is we had christened them as emergency lanes. There is virtually no approach embankment, only a 1 kilometer length of approach embankment. The reason behind it, I will come to it. It would form the topic of my presentation today. And the bridge viaducts are 6 kilometers long, and the navigable spans are 13 kilometers long. And the substructures were well foundation or caissons, and the viaduct portions were on piles. The bridge is being funded by Japanese funds. So partly Japanese funds and partly Indian funds. So when we started looking at the bridge, and when we started to plan the span arrangements, we had a few bridges already on the table. One is the second Penang Bridge, which is a sea crossing 24 kilometers long in Malaysia. And then there is one more bridge called Sutong Bridge, which is 8 kilometers long over the Yellow River. And all these bridges, their approach embankments are smaller, and they chose the entire viaduct, they chose viaducts to cross the entire waterway. So based on our experience in these 2 bridges, we thought how to we tried to adapt our experience on the hydrological designs in Dhubri as well. So we chose an extradose main span, which is 12.625 meters, 12.625 kilometers long. And then we have got viaducts, pre-stressed segmental 60 meter span modules. Now coming to how is the Dhubri-Fulbari bridge different from the other bridges that have been built on the Brahmaputra? There are 5 bridges which have already been built in the Brahmaputra, and almost all the bridges are either on a very constricted stretch where you have got rock on either side of the river, or there is a huge river training work which has been done to constrict the flow of the river. This perhaps is the first crossing which is braided and which does not have the conventional system of providing river training works and increasing the flow of the river. What we have done, increasing the velocity of the discharge. What we have done is we have created a viaduct up to the portion where the high flood level touches the embankment, and that's how the bridge became 19 kilometers. So this is something which has been an innovation. So coming to the alignment as such, there are two permanent river channels. Just a minute. Yeah, if my pointer is visible, at the location of the bridge, there are two permanent river channels. Like one is like this, which is the north channel, and then the south channel, and then there is one smaller river here, which is called the Jinjiram River. So we were tempted to create a guide band or a river training work along this channel and this channel, and that would have actually reduced my length of my bridge to a large extent. It would have been around 10 kilometers long, okay, or less than that. But then we weighed the options, and we found out we had gone for a hydraulic model study, which is there in the next slides. We weighed the options, and we found out that instead of going for a river training works, we might as well extend the river bank, extend the bridge up to the viaduct. Okay, so this is what we had done. And we had gone for a detailed survey of the entire location, which was like 20 kilometers upstream and 5 kilometers downstream. Why 5 kilometers downstream? Because there was an international border after that. So although we tried to extend our survey up to the 20 kilometers downstream, however, we were not permitted due to various international restrictions. So we, based on this survey, we developed a digital terrain model of the entire 20 kilometer length and width of 25 kilometers. So we developed a digital terrain model, which is 25 kilometers by 25 kilometers approximately. And then we actually, based on the surface data and all that, we went for a mathematical model study. Okay, the mathematical model study actually gave us the scours which were there. The scours had various flow conditions, and we have based our design based on those covers. Instead of following the conventional Lacey's formula, which we do in Indian Roads Congress, we have gone for these covers. Well, okay. Now there were questions raised that whether these covers are foolproof or not, and whether this would be this is applicable for a bridge which is will be designed for 120 kilometers. So what we did, we went to two institutes. One is both under the Ministry of Water Resources. One is the IWAI, Indian Waterways Association, and two is the CWPRS, that is Central Water and Power Research Organization in Pune. IWAI had given a clearance on the waterways of on the overall length of the bridge configuration, and IWAI had done a physical model study, as you can see here, the physical model study of the entire bridge. And they have actually ratified the scour data, and which we have actually adopted for the bridge. And so we got approvals from IWAI as well as CWPRS. So this is something which is path breaking, we should say. And this is how the bridge was, the bridge hydraulics were designed. So as I said, we had IWAI had given a restriction on the bridge spans that it has to be a 120 meter clearance, so it makes 125 meters center to center, and at HFL we had to maintain a 10-meter clearance for the barges to pass. Now we tried to convince IWAI that there are mud islands or riverine islands over the entire stretch, and we do not need this sort of a clearance at those places. But IWAI told us that they had given historical references also that nothing is stable in Brahmaputra, so the entire stretch has to be bridged. And we found out through satellite imaging of previous years, we found out that what they are saying, they had sense in what they're saying. So we had to follow this configuration. So this is all that I had to say about hydraulics of the bridge. And there were a few other innovations which we had implemented here. One is that we had given some armadillos. You remember I talked about having emergency lanes and service lanes. So between the emergency lanes and service lanes, we have given soft barriers where which are soft enough to be trespassed, but then there will be a notional barrier for people not to come. Only the ambulances would be taking this route. These are called armadillo separators, and these are used extensively used in the UK. And then we, of course, the intelligent transport system, it's no longer called an innovation, it's more of a requirement now. But then in 2015, it was still people were talking about it as an innovation. And then we have got camera on gantries, emergency response teams. We have boat ambulances and the maintenance speedboats. And the most important thing is people are there are residents on this temporary residents on these islands. So what we did was, it was a requirement from JICA, and we acknowledged it, that during floods there would be we should keep provision for these people to climb onto the bridge and take refuge, because the floods are devastating there. So what we had done is we had proposed some retraceable ladders for access to the bridge, which will not be there for during the dry season. Only during a major flood that we would be using the retraceable ladders to rescue those people. That is all that I had to say. Thank you very much for this, and I will look forward to the questions now.
Hello, Mr. Banerjee.
Yeah.
Yeah, so I have 2-3 questions for you.
Yeah.
First of all, regarding the project, the Brahmaputra Bridge, I wanted to know what is the current status, exactly the current status of the project, and what are the timelines?
Yeah, the project has started in 2020 December, and now the foundation work is going on. All the foundations are there are 101 well foundations, and around another 100 pile foundations. So all the foundation works, the 200 foundation works, are in progress now. And the timeline for this bridge is 7 years, 9 months, which becomes 2028 is the completion date, September 2028.
Right. And what are some of the strategies for the bridge maintenance also?
Yeah, the bridge maintenance strategies are being formulated by the. Let me tell you one thing, that since I am bound by a contract on this on the project management side, I will not be able to share much information about what is happening in the construction stage. But then but then we have a scope of work which includes that a maintenance manual will be prepared, and that would be rigorously followed. During the detailed design stage, yes, we had thought about ambulances and the motor ambulances and boats for inspections and gantries for inspections and all that. Yeah, yeah. But then the detailed maintenance manual is being prepared.
Okay, and any specific challenge that is being faced right now for the during the construction phase also for the project?
Yeah. It's challenge. Yes, the entire bridge is challenging. Yeah, it's not easy to construct a 19-kilometer bridge over Brahmaputra. The entire bridge is challenging, but then we are planning in a proper way, and we have India's largest contractor constructing it. So the challenges are getting overcome. The main challenge is actually the floods. We are like for 4 months we are not. The entire planning has been made in such a way that from between May and or September we are not going to work. Okay, June, July, August, September, these 4 months we are not going to work. So May is the last working season, and then anything we do in the monsoons would be a bonus for us.
Right. There's a question from the delegate. Does AECOM consider carbon emission analysis for its life?
Yes, we do. Yes, we do, and that is something which we have been mandated by our management to convince our clients. However, unfortunately, that was not in our scope of work, as you can see, and we had to stick to what the terms of reference had said. So, but then in all the now AECOM is not allowed to go for any bid where you don't talk about carbon emission control. But in 2014 it was not there, and it was not there in RTO. Had this bridge been bid for now, then we would have to have include this. However, there are we have got environmental experts in this project who would deal with these aspects as well. But then we don't have a definite tab on carbon emission.
Okay. There's another question from Mr. Devashish Bandapatiya. He is asking, have you considered wind structure interaction during the different stages of extra-door segmental construction?
Of course, we have that. Of course.
Okay. Right. And also, my last question to you, Mr. Banerjee, would be what are some of your future plans for not just the Indian market, but any such similar examples being seen, being taken up, like projects being taken up in Asia as well?
Yeah, we are continuously working in Asia. We had just come out of Joao-Macau Bridge, and yes, we are. We have a very strong presence in Asia, and we would love to participate in any project which is coming up. Yeah.
Okay. On that note, we'll close the session. Thank you, Mr. Banerjee, for your time. It was a very good presentation.
Thank you very much. Thank you.
Right. So now we would be having another short break, a 30 minutes break, and we would be reconvening at 2:30 as per SGT and 12:30 as per IST. So request you all to please join back on time, which is 12:30 IST, and 2:30 would be
3 p.m. 3 p.m. as per SGT.
Right. 3 p.m. SGT, sorry. Welcome back, everyone. We are ready for the next session. So for the next session, we have with us Mr. Randy Gautama Jovi, Petarani Project Engineer, Overseas Marketing, Wijaya, Karya, Beton. Before we begin with the presentation, Mr. Javi, I'll just quickly introduce you. So Mr. Randy Gautama Jovi is currently in charge of control, evaluation, and operation of overseas marketing of the Petarani project at Wijaya, Karya, Beton. He manages the department in carrying out the control, evaluation, and operation of overseas marketing of construction projects. He has previously worked as design engineer for various bridge construction projects in Indonesia. Mr. Jovi is civil engineer from Universitas Andalas. So we could begin with your presentation. It's going to be 20-25 minutes of presentation followed by Q&A.
Okay, thank you, Ms. Ishita Gupta. Okay, let me share my screen first to start my presentation. Excuse me. Okay, let me check first. Is the picture already available to you all?
It's visible, yes.
Okay, thank you. Okay, thank you for the opportunity from the Indian infrastructure already gave to me from Beton. And for this session for the second edition of the bridges construction in Asia, I am from Beton. We'll share about our experience and our expertise in the bridges construction, especially in the toll road development in Indonesia. One of the prestigious projects of the Beton itself is AP Petarani toll road project. In here, I'm going to give a brief introduction about this project and how this project is very important in the city of in the city itself. And most importantly, I am going to give a brief explanation about the technical value of this project that had the benefit for the cost, quality, and the progress of the project itself. Okay, as what Ms. Ishita Gupta already informed myself that for now I'm the manager of the cost control of the overseas marketing with the experience since 2016 in the IPCC LRT Jakarta project, the first LRT in Jakarta, and also in the toll road Petarani project, with several experience in the construction project staff from the site engineer and the construction manager. And for now, I am the manager of the cost control of the aviation operation of the overseas marketing of Beton. Before going to the next slide about my the toll road Petarani project, let me introduce my company first. A short, brief story about my company. Wijaya Beton is one of the most productive subsidiaries of Wijaya Karya, is one state company in Indonesia, which is focused on the engineering, production, installation of the precast concrete itself. And now we Beton are focusing on the market in Southeast Asia. So that's all about myself and my company. And moving forward to the project itself. Now in here, I'm going to show to all the participants and to the attendees that why this project is very important. Because the first thing is this project really improving the quality of life, such as encourages economic growth by reducing travel time to cut the time when people in way to the work for example to the work and then to the airport and etc. And also this project aims to improve the connectivity of the commercial and economic center in Makassar. In actual condition, this project also created more than 3,000 new jobs for the surrounding people in the Makassar city. And then this project also providing a better access for non-toll users, and for sure this toll road project aims to avoiding the flood itself. And beside of that, also why the project improve the quality of life is there is a shared knowledge to for example, to the student and to the university, and then it's like this moment to share our experience. Actually, also this project is the first in Indonesia, not about the toll road itself, but this project is the first project which is without land acquisition. Why? Because this toll road project is very important for the development of the Makassar city itself, and then the government of Makassar already prepared the area so the construction can run smoothly. And the project itself, which is located in this red point, we call in here South Sulawesi or South Celebes, exactly in the Makassar city. They are actually the first toll road in Makassar, so it's one of the monumental project in Makassar city. And also, speaking of the technical construction, is also the first time in Indonesia to apply the FPFS. I will share to you about our experience here, and not talking about the quality of life, the technical. We were also has a good quality and safety, which the highest quality material, the inspection of our product itself. And also with a zero fatal accident as the most important thing in the construction project, especially in safety. So looking at the development of the Makassar itself, the toll road is very important for the development, such as Makassar has planned for the construction of center point of Indonesia, and also to connect the Makassar new port. And all of this item really give the impact and effect to the economic growth and potential due to the traffic growth in the city. Speaking of the data, if you're looking at the growth of the Makassar itself, before the toll road constructed, the condition of the city is not supported by the rapid growth of the city itself. And as your information, the last toll road was built in 2007, and this is the last toll road. And then the rapid growth and lack of road development creates a heavy communication in the city. And it's just about the data, how much the growth of the traffic in the Makassar city itself. And we can say that the increasing of the traffic is very, very rapid and very high every year. And looking at the roadmap of the important point in the Makassar, which is the seaport and the airport. So the toll road will connect and give a faster access for the people to access the seaport and the airport as the important variable to a city to give a growth, especially in the economic growth. Okay, this is the brief project about this Petarani project, which was the foundation, used the bore pile and the pier box girder, and then the pier head by using the FPFS system of aluminum system. And also we applied the launching gantry to install the box girder. And then this the brief background about the name of the project, which started in the 30th April 2018 with the client PT Makassar Metro Network and PT Wijaya Beton as the main contractor, and with the supervising consultant from Nippon Koi, and with the length of the tower itself around 4375 meter. And this is just the information what the standard and codes when we use in the design of the construction itself. By using the international standard that already fulfill the requirement from the local standard SNI of the standard which applied and applicable in the European standard, and also the ISO LRT for the bridge and design specification. We also applied the American Concrete Institute and then other standard used in this project. So that's all the quality standard we use in the implementation of that. As what I said, that the quality is one of the more important thing in this project. Besides the updated technology we use, every single of the material we do the inspection, such as the fine aggregate, the coarse aggregate, the cement factory. We go to the cement factory itself to look at the process, and also the rebar testing as per the standard of the codes and use we use in that project. And you know that every single of the type of construction we use in this project has the philosophy itself. For example, the bore pile. We use the bore pile as we know that the bore pile one of the friendly environmental choice of the construction itself, because as we see at the map, the line of the Petarani project located in the central city of the Makassar. So we chose the bore pile because it shall be minimize the disturbance of the people activities. And others is the key or our construction in this project is by applying the flying pier head framework system or element system. That is mainly this construction is the first time in Indonesia. Why we use this construction? Because in time the average duration of the pier head work cycle is 14 days, faster than the conventional method, around 60 days. Is really give the advantage in time. Talking about the easeability and also improve the ease of the construction work with less disruption and minimize the disruption and assisted and also safer since this project located in the central of the city itself. And how about the cost efficiency based on the study and also the actual experience? Almost 20% of the cost efficiency rather than we use the conventional method. So if we look at what is different between the conventional and the FPFS is the conventional, the installation of phosphor is required, but in the FPFS or element system not required. So these very give the benefit. We are not going to use larger access. We are not going to make a kind of more disturbance when the project running. And then duration of the conventional longer than the shorter, because we need as we know that conventional, we need to use the scaffolding installation, the scaffolding after the work finish, we need to demolding the scaffolding itself, but not with the FPFS, which is already in all the rebar, all the foam already installed and ground, and after all complete, we install in the up of the pier head. And the traffic times also conventional very high, the traffic transfer, but the FPFS very less. And also this project also applied the balanced launching gantry. We used 2 launching gantry during the installation. And as per the data, the average cycle time of by using the balance launching gantry really give the benefit during the construction. And then this is the proven faster erection cycle time method, because the erection process could achieve within an average 4 days for 1 span for 2 days. And it did based on the experience, the fastest cycle was 3.5 days for 50 meter span. not only about the construction method, the bulk girder that produced by Beton very meet the requirement with the tight checklist inspection by the inspector of the Nippon Koi. And Beton is the trusted supplier with a detailed analysis, and then the quality is very guaranteed here by Beton with the certification already certified by international standard. And also not only that, we also apply the LRB implementation based on the calculation of the based on the location and area. And also the linking slab also installed, and then for the expansion joint here, we install every 350 meter. That is used to Indonesia. In Indonesia, every 100 to 150 meter installed. But in this project, we installed 350 meter. Why? Because this gives the more convenient for the driver when use the toll road, and then more efficient, and then less maintenance, because the quantity, the number of the EJ shall be less than what it used to be. And others, the structural SHMS also installed in this project to check the actual condition of the structure itself. Beton also give the contribution of the design and also the installation of safety health monitoring system of the bridges itself, with the concept of what I share in here. And also during the project, we can meet the zero fatality with 5 million working hours without lost time and injury. And also during the construction has less traffic accident during construction. Also, we also consider about the environmental awareness, such as we do the periodical environmental measurement about to check the noise, and then there's no land acquisition. More than that, solve the flooding area in this area, and also replace the HDPE water pipe during the construction because of the boring of the foundation itself. And as one of the program of our project, we also support the green infrastructure, which is we plan around 5,060 trees surrounding the Makassar city. So this project also support for the green infrastructure. Not only that, we also think about the efficiency of the LED energy. So this project also save the electrical energy power by 50% by using the LED energy efficiency. And along the side of the toll road, we also upgrade the outer road safety and comfort with add another facility of the beside of the toll road, such as the sidewalk crossing, and then access transport facilities, and give the comfort of the user of people beside of the toll road, and give the safety and security. And also put the guiding, paving, wayfinding signage and ramps for the universal use. This project also contributes to community. We also think about the sharing knowledge to others, so anyone can understand about how the Petarani constructed, especially for the FPFS construction itself. And also give the impact for the social, such as the social activity with the people around the project. And also by construct the toll road, it gives advantages for the people around the area. Almost 3,000 local labor were absorbed in there. and then give the benefit for the local vendors, such as the mini market around the area. So the conclusion is this project boosting economic growth and then give the national happiness, and with high quality implementation with the most updated technology for such as the FPFS construction, with which is give the cost benefit and quality of that self, and give which is the latest innovation in the construction. And not only that, we also can achieve the zero fatal accident as one of the most important in the construction, and also supporting green infrastructure. And the last is this project has awarded in the second Best Project Award in Philippines category 1 for the high volume award around last year. And then this Petarani toll project designed to give the social impact, not only for the user, but for the social impact, which is concerned to the innovative technical excellence and keep carrying on the environment as the core of Earth sustainability. So that's all from our side regarding the construction of toll Petarani. What I can share to this conference, Ms. Ishita Gupta. Thank you.
Thank you, Mr. Jovi. We have a few questions from the delegates for you. My first question is, how could the FPFS affect the time and cost of the project?
Yes, for sure, the application of the FPFS gives the time benefit and cost benefit, which I mentioned previously. The conventional method use around 60 days, because you need to install the scaffolding and then etc. work, the additional work. But in the FPFS, you don't need to install that, which only consume around 14 days. You can start the concreting for that itself. And how about the cost? Yeah, if you talk about the cost, the cost, it also, as what I mentioned previously, based on our experience in the Petarani project, give the efficiency almost 20%, because you don't need to take more time, which will impact to the cost itself. You don't need to more people to install the scaffolding, which will affect to the cost itself. So there are so many variables which affect to the time and cost, Ms. Ishita Gupta.
Okay. Another question from one of the delegates is, does balanced launching gantry affect the time of construction?
Yes, the balanced launching gantry really affect the time of the construction. Besides of the design of the toll road itself, this construction method give the effect. If you can see previously in my slide, the average time really less than the conventional, really less than use only one launching gantry. Yeah, so the answer is yes.
How do you minimize the utility connection issues for substructure construction?
Okay, excuse me. Excuse me, Ms. Gupta, could you repeat the question?
Okay, so I'm asking, how do you minimize the utility connection issues for substructure construction?
Yeah, for that one, we also consider the issue between between the issue of such as the connection between, if I'm not mistaken, between the AJ, the expansion joint, and also the linking slab. For the linking slab itself, we also do by the concreting. So the connection between the link slab will connect it gratefully.
Okay. And what is the tolling pattern and rates of tolls for the project?
Excuse me?
What is the tolling pattern and rates of tolls the toll rate for the project?
Oh, sorry, my connection is not really good. Excuse me.
Okay. Are you able to
maybe
hear
you
me
can.
now?
Hello?
Can you hear me now, Mr. Jovi? I think there's some network issue.
Wait.
Wait. Mr. Jovi, am I audible?
No. So sorry, my connection is not really good.
Okay. Can you hear me now?
Oh, maybe you can. Text in the chat for the question, so I can hear.
Basically, the delegate wants to know what are the toll rates for the project.
The toll rates.
Yes.
Toll rate. Oh, the toll rate. Okay, for the toll rate of the project, you mean what's tolerance?
The tolling rate.
Oh, the tolling rate.
Yes.
The tolling rate. Let me check let me check and then give the response.
Okay, not a problem. Also, one last question is, what are the bonding agent or additives used to bond between two precast concrete box girder? It's the additives used to bond between two precast concrete box girder.
Oh yeah. For between two precast concrete, we use the agent or additive to bond two precast. But for if you talk about the brand, we use most of that, such as Sika and etc. We use the agent and additive to bond it.
Okay, and there's another question, Mr. Jovi, for you. How is the Aluma system compared to Source to Bahu Tech?
Okay, for the Sosro Bahu Tech, I think I need to get a study for the Sosro Bahu Tech, but the Aluma system for now, what I can share to Mr. Edwin.
Okay, and which type of expansion joints are used in the bridge? Which type of expansion joints are used in the bridge?
Yes, the expansion unit type of kind of same kind of like a rubber and then the steel plates in the expansion joint, but we only install every 350 meter to give the convenience for the driver.
All right. Okay, on that note, we close the session. Thank you, Mr. Jovi, for your time. And
thank you.
Good luck with you.
Thank you.
Thank you. We're ready for the next session, which is on bridge projects in the GCC. The session is going to be moderated by my colleague Akamsha. Over to you, Akamsha.
Thanks, Ishita. As Ishita mentioned, we are now ready for the last session of the day one of this conference, and that is on bridge projects in the GCC, and we'll be, listening to certain case studies that will be presented by Mr. Francisco Presta, Technical Director, BG&E. Mr. Presta is here with us already, and before I request him to make his presentation, I'll quickly introduce him for all our delegates.
Hello. Good morning, good afternoon.
Hi, Mr. Presta.
Can you hear me and can you see me well?
Yes, sir, I can hear you and we can see you. I will just request you to start sharing your presentation, and in the meantime, I'll just introduce you for our audience here.
Let's see if I hope it works. So you tell
yes,
me
yes,
you can see it.
Yes. So just allow me a minute to introduce you.
Sure.
Mr. Presta is Technical Director for Bridges at BG&E Middle East. He comes with 2 decades of international experience in the field of structural and bridge engineering. His expertise covers a wide range of structures, including highways and railway bridges, footbridges, cut and cover tunnels, and other complex one-off type of structures. He has extensive experience in value engineering of large-scale infrastructure projects, including metros, railways, and highways, with a particular emphasis on producing alternative valued engineered solutions to optimize costs and program and improve constructability. Mr. Presta has a PhD in computational mechanics and a degree in civil engineering from University of Calabria. Welcome, Mr. Presta.
Thank you very much. Thank you for the kind introduction, and thank you everyone for joining this session. I will be talking about project in GCC. My name is Francesco. I'm based in Abu Dhabi, and the project I'm going to present today are projects we have developed in the UAE and in Bahrain. I hope you can see my slides properly, and this is the introduction that's already have been given, so I will not spend a lot of time on this, but mainly I have spent most of my career internationally, based in the UAE most of the time, and I've been involved. I've been lucky enough to be involved in projects around the world, including the UK, Middle East, USA, Far East, and most recently in Australia. Quickly about my company, BG&E. It's a design firm established in 1970s in Australia. We have almost 900 employees, and we are 100% employee-owned. We have a lot of experience in design and build projects working for contractors. The project I'm going to present today are mainly two. The time frame is not too much, so I'll try to make it not fast, but at least give you an overview of the project. And if you have any question, of course, please let me know. The project is the Etihad Rail, for which we have been involved recently here in the UAE, and another project is SAR interchange in Bahrain. I'll start with the Etihad Rail, for which we were involved in the package 2C. The overall parties involved in the job, the main parties involved in the job were, of course, Etihad Rail as a client, the construction JV made by China Rail and Gantut construction company. The lead designer was WSP, and we were subconsultant to WSP to design part of the bridges. If you are familiar with the project, Etihad Rail is the UAE national railway network design, currently under construction. It's subdivided into different stages and packages. This one in particular is the one we have been involved recently, is package C. That is a stretch that goes from Jebel Ali, which is the industrial area of Dubai, up to Sharjah border, 94 kilometers. And that's of course a plan of the project. I'm talking about stage 2C, of course. And in particular, the bridges I'm going to discuss today are in the Jebel Ali branch, which is JBL, marked in this plan, and DMC, that is the branch that goes up to Sharjah border. Standard for the project, it was of course local standard, all the local standard and specification, but mainly the under bridges, which is the rail bridges, were designed according to ARIMA, is the American Railway Code, and other codes, of course, in support where the code was not covering some of the aspects, or maybe to have a more stringent or more careful design. ARIMA code is mainly a freight. ARIMA design includes the train load called Cooper E80. It's quite a heavy train load with axle of 360 kilonewton each. The rail is a freight rail. However, we have designed it also to accommodate passenger, with using the Eurocode load model 71 with a maximum speed of 200 kilometers per hour. Interesting to to say that we have the design for 3 levels of earthquake, what we call serviceability, ultimate, and survivability. All of them with, of course, different intensity, return period, peak ground acceleration, and different design approach. The earthquake had no live load coexistence in the design. The main design consideration were, of course, the design and build project that was driven by the program, of course, fast track, as usually is in design and build project, in particular in the UAE. Constructability, with of course, with an option to make it buildable as much as possible, of course, without major delays. Span optimization, when we do long bridges, of course, we try to optimize the span to make it repetitive as much as we can, and with rail bridges, this is generally the case. Maybe using simply supported span of similar size when it's possible. Durability, of course, always a key element. There was a durability assessment report done for the overall project. So we used, of course, the determination from that report. Maintainability, of course, is an eye on how the bridges are gonna be inspected and maintained over the design life. Seismic effect, as I mentioned already before, there was a seismic hazard assessment report done for the overall project, and we used the finding from that report. Generally and usually, a solid structure interaction is included into analysis and the design, and it's the same. Fatigue was very important for the steel bridges, and fire, because the client wanted the steel bridges to be fireproof. In terms of analysis, we used all sorts of analysis you can imagine for complex bridges, from within finite element modeling, linear, non-linear analysis, up to, of course, dynamic analysis for establishing the amplification factor and the passenger comfort. The first bridge we have done, there are 2 bridges we have done, 2 viaducts we have done for the Etihad 2C. The one is called the JBL, it's the Jebel Ali branch, I say is 1.3 kilometers long. It's made of 36 simply supported span with variable length of between 17 and 72. The bigger span are made in steel. The other are post-tension box girder. This is the arrangement. Pretty, of course, standard simply supported span. As I said, box girder most of the places, whereas in some places you can see there are steel span, particularly where we had obstacle and the bridge was couldn't be built as cast in place on formwork. Again, you can see this is the same general arrangement. You can see that there are steel span up to 72 meters on the right hand side and 55 meters. Whereas the DMC was all post-tension concrete box girder, and some of the bridges were continuous to some constraint in the design in the site, so we had to go for continuous bridges. This is again the GA of the DMC wide. As I said. Bridges were post-tension concrete box girder, typical single box for the track, double track rail. You can see, of course, the envelope in here, and the cross section has been somehow recalling a previous section used for the stage 1 of the project. So, and the architecture is not much really invented in this particular case. The simple span, the box girder were, as I said, single cell box with blister in the inside for future post-tension. You can see on the side the client wanted to assure that there was possibility to increase the post-tensioning of the deck if later the live load would increase. So quite heavy structure because the loads are quite heavy. The design criteria were quite strict, so we went to design zero tension or SLS as a visibility. So you can see a lot of cable draping within the webs, or also in the slab to make them more efficient whenever it was possible. Bridge under construction. Most of the bridges the cast in place box girder are erected on false work because there is no main constraints. Some of these run through the desert, but in some area that was not possible, of course, and we had to change the construction type to steel. We will see where. So these images of the construction, of course, you can see quite heavy reinforcement, and the ducts being laid within the web, heavy diaphragm to transfer the lateral loads. You can see on the back of this the Dubai Metro. Basically, this bridge continues below this the Dubai Metro, and then in that case we'll go with steel structure that will be lifted and transported below the metro to avoid any interaction during construction. Standard concrete piers used in the project. Two bearings to support two pair of bearing on each pier to support the box girders, supported on piles, on bored piles. Of course, where the deck, of course, were simply supported, and to support the ballast, there was a cover plate between the two deck, and there was a fascia to protect the gap as well. As usual in the UAE and in many places where there are a lot of sand, we use dust cover in front of the bearing to avoid contamination from south. Stepped pier is where, of course, the steel bridge and the concrete bridge meet. They've got different depth, of course, so we need to resort to stepped piers. And abutment, it's single row piles, simple as abutment, and you can see at the back we used MSC wall to reduce the transfer, of course, of the lateral pressure to the abutment. So the abutment effectively brings carry only vertical load into the soil. This is the step here I was talking about before, where we have the steel bridge connecting to the at the interface between the steel bridge and the concrete deck. The steel bridges you can see is made of is a truss bridge. This is the 72-meter span bridge made with standard Warren, if you want, arrangement. Two main truss on the side, cross girder connecting the two truss, and the top bracing to connect the top cord of the truss. This is a cross section. Again, the envelope, of course, is the same. A little bit of attention in a way to make sure that the ducts and the service trough were continuing between the concrete box and the steel deck. On this, eventually, there will be some cladding for advertisement applied on one side. So we have to design for that as well. Some details of the node, quite heavy fabrication. I'll show you some picture in a minute. Mainly the bottom cord are box, the top and bottom cord are box type element. It was a requirement from the client to have them as a box. They didn't want open section. Of course, the fabrication of box section is a little bit more complicated, but that was the client requirement. The client also wanted the bridge to be painted with a fireproof layer, and also painted over and above that. We will see some picture later. So you can see box type of section on the bottom cord, quite complicated details where the raking and the vertical post meet to the bottom and top cord. This is the top corner of the truss, of course. We had other bridges, other small bridges. This one in particular, there were 5 bridges spanning over Sheikh Road, quite big bridges, quite a big road. So we had to consider a method of erection, which is effectively building the bridge next to the site, and then put in position with using SPMT. The bridges are ready on site at the moment and are waiting to be lifted in place over Sheikh Zayed Road. The smaller bridges were not closed section in a way with top bracing, but it was an open trough type of section where the top cord, of course, is not braced. and that's and you can see there is not of bracing here. It's just an open new trough. Cross girder, of course, between the truss, we had this steel girder with longitudinal girder also spanning between the transverse girder with a composite section cast in place after that. The section, the top slab was formed with permanent and structural deck planks made of thin plate, 6 millimeter thick plate, and some trellises, so that it will be like able to support the weight of the wet concrete when before the pour. You can see a picture of what I'm discussing so far. This is for the small 29-meter span, the one on Sheepshead Road. You can see the trusses, of course. You can see also the white is effectively the fireproofing painting. And you can see the transverse girder with the studs and the steel planks, the precast steel planks that were spanning between the transverse girders. A little bit on the fabrication, of course, some complex fabrication to do. The steel would be, of course, being cut with numerical control machine. Of course, this is the diaphragm of the cord, in particular, being cut. All the pieces being cut, and you can see some of the segment being fabricated in the factory. This, in particular, is one of the nodes. And this, of course, is again one of the nodes of the steel truss. In terms of the stages, after the element have been fabricated into pieces, been transported into site next to the construction site, where they've been assembled on temporary towers. This, of course, the temporary tower has been built on site, and then the bottom cord of the truss is being assembled, and then on the other side as well. Then transverse members being butt weld, so that to connect the two bottom cord. And of course, moving forward with the same, completing, of course, the bottom part of the bridge deck. Then there's the time of the top cord with the diagonals and the raking ends. So I'm going a little bit faster here just to show you the sequence that have been used for fabricating these things and for building these things. The element have been, of course, fabricated in the factory and transported on site. So upon removal of the scaffolding, of course, the deck is ready to be transported. I'll show you a video later of how we anticipate to transport these things. Unfortunately, it hasn't been happening so far because of the expo. They kind of delayed a little bit the erection of these bridges. This is ready to go deck. You can see some of the detail in here as well. Again, the fabrication, but also the painting for fireproofing. This is more evident in here. And this is the bottom of the deck. This is one of the deck, of course, is the 25-meter, the 29-meter span. Some of the details with attention not to accumulate water and to drain the water from of course, as much as possible. This is the small span. This is one of the small span. I think it's the 21-meter, already ready to be erected. And this is 29-meter. And it's being painted as well. You can see there are some attachments in here that have been attached later to support the advertising panel board. And these are just ready to be erected. Some more picture. And this instead is the construction of the 72-meter with top. You can see there are top bracing in here. It's not an open section. Again, few pictures here and there. You can see that top bracing being placed at the moment. It's still under construction. I have a small video, if it works. I'll show you how the construction is anticipated. If you can see it, I hope. for the construction. Mahmoud was in charge of the construction. A little bit of information about. I'm not sure if you can see it, to be honest. But,
we can see it, sir. Mr. Presta, we are able to see it.
Okay.
Yeah, but we're not able to hear anything, but we can see it for sure.
Oh, I don't think there is. I don't think there is a video. Sorry, there is a voice or anything.
Oh.
Because the picture are not great actually.
Okay.
I'm not sure if it's coming. It's supposed to be more clean actually. It seems to be not showing properly. No, it's not. Unfortunately. I'm really sorry. It doesn't show really. It's supposed to be a color video. It's not black and white. You see black and white, or you see?
We can see black and white here.
No, it's not meant to be. But effectively, what it is that this video is not showing properly. It's supposed to show that the deck, once it's been erected, has been fabricated, erected, is going to be moved into these devices that are going to lift the bridge a little bit, so that these are this castellated structure that bring the bridge up, jack the bridge up to a certain level, but just below the Dubai Metro, so that it can move below. You cannot see much here, unfortunately, but after this PMT come in and will transport the bridge below the Dubai Metro up to the final position. I think I would probably better to fast forward this because it's not much you can see here. Yeah, you can see this PMT coming and then transported on site, with the bridge being lifted on Sheikh Zayed Road. I'm sorry that the video doesn't show really the detail, but there was a video done preliminary just to show the construction sequence. Okay, if again I'll move into the second project, which is a little bit different from this. Is more different construction method. This one is in Bahrain. It's a ramp built for an interchange in Bahrain for the Ministry of Work. Contractor Al Ghanim with specialist subcontractor DSL. We were the lead designer for this. As I said, the bridge is in Bahrain, and this is the SAR interchange. It's one of the main interchange in Bahrain because it leads the Sheikh Isa bin Salman Highway, which is this one bring to King Fahd Causeway. If you are familiar with the place, is the main connection between Bahrain and Saudi Arabia. So what we did is that we designed a flyover of 115 meters long with a radius in plan of 203 meters, a total of 14 span with 40 meter long main span, with a 30 meter long main span. That's important because it's going to determine the method of construction as we designed the bridge as incrementally launched. And the bridge was designed to Ashton. This is the ramp. This is of course the general arrangement. You can see, you can appreciate the curvature, 203 meter radius. It's quite tight, just as usual for a ramp. Basically, when we got on board on the job was not built. Was going to be built with a different construction method. So hence, what we did is that we redesigned the bridge to be incrementally launched. Incrementally launched, of course, there are certain geometrical constraints to use, and we had to adjust the profile. The plan was a constant radius, which was okay for launching, whereas we had to adjust the curvature in the elevation to make it launchable. So we had to adjust, and we made it another the elevation. We adjusted the elevation to make it as a radius. So the bridge was launching double curvature. The way it worked is that we basically the bridge itself, the ramp, is gonna be was designed to be as a arc, part of a bigger sphere with the same radius in plan, basically. So this is effectively the line defining the ramp in the space, if you want. So so what you did when you launch a bridge along an arc, is that the constant section is practically extruded along the line in double curvature, so that the section remains constant, and there is a change in the grade that transform on the summit to become a crossfall. You can see that the crossfall in here is 0, but the gradient is theta. And when you reach here, the crossfall is theta, and the grade is 0. The gradient is 0 by this solid zone. So there is a transformation. The cross section remains constant.
Mr. Presta, sorry to interrupt, sir. We have about 6 to 7 more minutes.
Yeah, no, I'll go fast. I'll go fast, and I'll leave some time for
some questions as well. Yeah.
Yes.
Okay. Yeah.
So cross section is a box, double cell box girder with thin 375 thick web, and which becomes slightly bigger towards the pier because some of the bridges are continuous, and with some cantilever 1.8. We have 2 cells because the client was worried about cracking in the top slab, so we decided to go for 2 cells. I will not go into details, but effectively we're not able to do the constant cross section eventually, because with a constant cross section you have a variable crossfall, which the client didn't like. The client wanted to have a constant crossfall in the ramp of fine half percent. So we had to effectively adjust the height of the webs so that along the launch, eventually in the permanent condition, the crossfall of the deck was 5.4%, which means that of course we have to change in the construction yard, we have to change the depth of the section continuously. So that's what I'm talking about. If it was a true launch, we will not have changed anything, but this one was launched, and we also had to adjust the crossfall to make it achieve in the permanent condition the desired crossfall. So we had to, of course, to build a 3D model for this. Otherwise, the geometry would not be impossible to describe. And there's some details in here. So this is the launch. And we had to provide, of course, the setting out point all over the place, because eventually, because the deck was changing continuously along the length, every 1 meter, we provided the depth of the section. So concrete piers and standard concrete piers big enough to host the temporary jacks and the possible jack for lifting the deck in case of pad jamming, and temporary bearings for launching. And you can see the bridge being launched. You can see that you can appreciate the double curvature of the deck with the launching nos on the top of this, and the concrete piers that, of course, have got guides on the side to restrain the deck during the launch. Construction yard on the back of one abutment. The client wanted to build the box in different phases, the bottom slab and the webs in one moment, and the following stage complete the deck with the top slab. So the deck was arranged in different areas. Area 0 for the rebar, area 1 for the W section, which is the bottom slab with the webs, area 2 for the top slab, and area 1 where the nose was assembled at the beginning. So you can appreciate that, of course, this is the stage when the nose is assembled, and the stage in the first step. After that, the bridge is pulled from one abutment, from this abutment here. We had a total of 26 segments of about 20 meters, and the cycle for each segment was 1 week. The bridge was launched as a one element, 515 meters long, and then after reaching the final position, it was split by pushing the other element back in position to create the gap. This is some picture of the construction yard, where the W section is assembled, and the area 2 is where the top slab is assembled. You can see a picture from the inside. Deck is quite clean. You can see there are no blisters in here because we haven't. I'll show in a minute that we haven't used second stage, the post-tensioning, for the continuity of the deck, which is quite an innovation. This is the phases of construction, and of course the bridge being pulled from abutment A2. This is the section built in area 1, which we call W section, without the top slab, and then after that the top slab is built. The nose, which is about 60% of the main span, as I told you, 40 meter, so it's 25 meter, made by 2 girders, also curved in plan because they need to fall. You can see they are kinked to fall the radius of curvature of the deck. And of course, the nose is attached to the front of the deck with PT bar, quite heavy PT bar, to allow the transfer of the heavy bending and shear that are coming from the construction. You can appreciate there are guides all over the place, abutment and piers. And this is the launching nose going on top of highway. Of course, the main benefit is that highway was not affected at all from this. They saw the bridge running over them through construction, and they never stopped. The highway never stopped to be live. Basically, general arrangement: pulling sticks, pulling jacks attached to one abutment A2 in this particular case, and some pulling sticks that go through the deck that allow the stand to pull the deck from the abutment from the abutment with pulling stand. Basically, you can see this is the jacks attached to the abutment here, and this is the arrangement, of course. Abutment, the devices to attach the jacks, strand, and the structure to the steel structure that transfers the load to pull the deck effectively. Sliding pad, of course, you can make use of sliding pad for launching a bridge with temporary bearings on each pier. Sliding pad are made of rubber and Teflon, so that to allow the grip to the top to the bottom slab of the concrete, and to allow Teflon to Teflon sliding on top of the temporary bearing. You can see the picture of the temporary bearing made of Teflon, of course, and to allow also the easier sliding of the deck on top of it. You can see the shape of it is a little bit rounded, and to allow the sliding pad to be inserted every stage, for the move of the deck, let's say. You can see a lateral guide on each pier, designed, of course, to maintain the bridge in position in case during the launch, but also during when the bridge was waiting to be launched for temperature expansion, contraction, and so on. And you can see the sliding pad on top of the bearing, or the launching bearing. You can see the sliding pad made of rubber, and you can see a layer of Teflon on the bottom, just to allow the easy slide of the structure. Interesting for this bridge was designed as post-tension, of course, as I said, but without, as usual in incremental launch, there is a stage 1 and stage 2 post-tensioning. The stage 1 is generally concentric, and to allow the launching, because the launching change, there is a reverse of bending moment through the construction within the deck. So generally the first stage PT is concentrical, and then there is a continuity, second stage post-tensioning at the end. Instead, we designed without the second stage post-tensioning, and we just by putting the post-tensioning in the right place and stopping and starting the post-tensioning, we managed not to have a second stage post-tensioning, so no blisters, and the deck is really clean. And the final solution became very clean and not messy at all. And this is the arrangement. I don't go in details on this, but effectively starting and stopping the strand in the bottom part or in the top part, depending on where the final section will be, allowed to avoid the second stage post-tension, which is a good advantage for the contractor as well. This is the launching, as I told you. We launched the bridges all together. So once the 515 meter reached the final abutment there, so what we did, we had to push back the two parts and then the single part in order to form the 200 millimeter gaps. The segment were cast back to back, match cast with bond breaker and the PT bar to connect them. After that, after the bridge reached the final position, the bar were removed, and one the bridge was pushed back using these blisters that were put inside just to allow the jacks to push the bridge back. And you can appreciate how many PT barriers to put to launch the bridge together with diaphragm to be that have been, of course, dimensioned for these heavy forces. And you can see the bridge being launched, no traffic disruption, very successful. The bridge received an award in Bahrain for excellence in construction, in highway bridge construction. And this is the final bridge being launched. You can appreciate the curvature from here. The bridge in here is almost reaching the final abutment, and this is the bridge open to traffic. I have completed. So sorry if it took a little bit longer than expected, but I'm happy to respond.
No, not at all. Thank you so much, Mr. Presta. It's just that we have a couple of questions, and we wanted you to spend some time.
No worries.
So the first question is from Mr. D. Sarangi. He is Additional Director General from Ministry of Road Transport and Highways, India. He's actually representing the Secretary of that ministry. His question is why the span arrangements are so different. Is it for navigational requirements or any other reason?
In which bridge? Sorry,
I think he had posted this question after you discussed the Etihad rail. So I'm assuming it's for that.
Etihad rail, I can go back to this. Typically, in the span is dictated by in the UAE. There is a lot of utilities. Even if it's in the desert, it will seem strange, but there are a lot of utilities. For example, like in this bridge here, but yes, I'm not sure if you can see my screen.
We can't see your presentation.
Okay.
Now we can't.
No,
see
look, I mean, the span, we tend to do the span as standard as possible. You are correct. There is no navigation, but the main obstacles were the big roads when they are not in the desert, and when they are in the desert, there are a lot of utilities, and typically we try to avoid the utilities, but of course we try to make them as standard as possible, and sometimes that's not really feasible. But the idea is to do the standard as possible up to a certain maximum span that is the one that determines the size of the cross section. Yeah.
Thank you, Mr. Presta. There's another question on substructure pattern of GCC. Is it different from South Asia? Because South Asia, and especially countries like Bangladesh, has siltation and other issues. So are there any salinity issues faced in the GCC?
Oh yeah, of course. It's salt. The environment is very aggressive. There are chlorides, sulfates, and we tend to work, particularly in the foundation, we tend to work with quite big concrete cover, and we tend to have dense, compact concrete. Sometimes we have concrete replacement for concrete so that to improve the durability of the concrete structures. Yes, I mean the high chloride, high salinity. Yeah, I would say yes a lot. It's the Middle East is a lot of sand and salt. The soils, there is a lot of sabaka as well, which is a mix between sand and salt. So it's very salty, very lots of chlorides. Yes.
Okay. How did you fabricate the bearing stiffeners in bottom chord, closed box? I think this is also for Etihad rail.
Oh yes, I mean this is there is a stage. Of course, the fabricator, along with the fabricator, we put together the sequence of the panel being assembled. Of course, sometimes you need to weld from one side only, maybe a V-shaped weld from one side only from the outside, and the stiffeners inside, because the segments were assembled in panel, generally a stiffener can be welded from one side or can be welded from the other side, from one side only. Sometimes, in certain cases, when it's not possible to do a welding, some panel are also disconnected from the stiffeners inside. This is not our case because for us was possible to weld from the stiffeners, but in general, you can also, when it's difficult to get into a place, some of the stiffeners can be also disconnected from one plate in alternate way. So.
I think the next question is also on bearings. The question is which types of bearings were used in Etihad railway projects and in the grade separator?
They were all mechanical bearings, so spherical bearing. There is, of course, enough information that says spherical bearing are more durable. Was a client requirement, in fact, to use spherical bearing and the ATR rail. The loads were quite heavy, of course, as you can imagine. On rail project, the loads are quite heavy, so somehow discarding already spheric bearing as such. In the ramp for the ramp in Bahrain, as I told you, we modified the design already produced, and so we use the same bearing that were supposed to be used before, which are spherical bearing. They used selected by the ministry because of durability.
Okay. In fact, there's another question from the same delegate. This is Mr. Gaharwar. He's asking how the segments for the grade separator of 20-meter length joined together by pre-stressing. Generally, the segments are of smaller lengths.
You mean for the incremental launch?
I hope so, yeah.
Yeah, this is not precast segmental. This is cast in place, incrementally launched. So the construction yard has been set up to cast segment of 20 meters. 20 meters is typically 50% of the main span, which is 40 meters. That's an incremental launch. Typically, you cast segment that are 50% of the main span. So the segment are like there is a bar, continuity bar sticking out from the one segment. Plus, there are some of the tendons stop at each joint. Some of the tendons are full. Typically, there is a number of tendons that continue to the next segment, and some of the tendons are stopped with or connected with couple. So there is a continuity between the segment, which is normal also rebar going through, and the PT going through the segment. Not 100% of them, because as I told you, we stop some of the tendons here and there to allow this avoiding the second stage post tension. But it's not precast, because in precast, maybe I was not clear. This is not precast segmental, where the segment are 3.5 meters. This is cast in place. And I went, sorry, I had to go a little bit fast on that. The yard is about, there is space for casting 20 meters, 20 meters, 20 meters. The cast is about 100 meters. Just the casting yard is about 150 meters, just to be clear.
So there's another question which says that given the extreme weather conditions in UAE, what are the measures that are being put in place to address these weather conditions, especially in relation to steel truss and bearing plates that would end up compromising the structure?
Yes, I mean, this is a good question as usual. And when you're still in the UAE, it's the main question. First of all, I have to say that the steel structure were used because, of course, there is a need for it. Otherwise, we will go with concrete as well, to be consistent with all the other parts. No? But to span 72 meters, we decided to go with the steel structure. Now, the steel in itself, it's weathering steel, and which is in itself probably it typically tend to be kind of create a patina to protect itself over time. Although in a marine environment, it's not typically the material that is selected for this environment. So on top of that, the client wanted it to be painted, so protected for durability. So typically triple layer of three layers of protective painting with a primer and a couple of layers, small layers of other 2 layers of protection. And this generally give a good protection for steel over the years. Of course, the bridge will need to be monitored and as usual maintained to allow for to be. In terms of the bearing comes from manufacturer. They come with and they're also protected with what we do is that we tend to protect with the bearing shelf with the cover, with the bearing shelf covers to avoid salt to go inside and contaminate the bearing, because salt, of course, transport chlorides, sulfates, and so this is surely minimized. Yes, I mean these are provided, bearing then are provided element that are, of course, guaranteed to last a certain amount of years in certain conditions. So, yes.
There's another remark, Mr. Tirtha Roy is asking that if you can give an idea of pulling force that is being exerted.
Oh yeah, it was there. It was there. It was about 500 ton.
Okay.
Because it's of course we had to pull the full deck. The full deck.
Right.
You see, there was double curvature, as I said. There was a plant curvature and there was a elevation curvature. Of course, as the deck go up, of course you have to consider the weight of the deck plus the gravity, which is the gradient of the deck. Plus there is the friction, of course. But the overall weight of the deck was about 500 ton, and we were able to pull it with 2 jugs.
Right. And Mr. Presta, this is the last question for the session. Basically is value engineering applied on these projects, and what is the criteria to be followed if you're doing value engineering on bridge projects?
Yes, I mean, value engineering is about, of course, I guess from the engineering point of view, it's about maximize the use of material and also try to even in terms of using of material when it comes to environment and reducing the use of material and so on. But on a project like, for example, in Bahrain, we didn't change much on the job. We mainly changed the construction sequence, and with a positive impact. That's value engineering for us, as the client wanted to avoid the traffic impact, which is also at the end of the day impact on the environment, because you can imagine on a big highways not too close to the traffic. So we launched the bridge, we built the bridge without the traffic not even noticing that there was a bridge under construction, and the people driving will notice the bridge flying on top of them as they were driving, and the outcome was great because it achieved the purpose of the value engineering. Value engineering, of course, it can be using the material in a better way, but also providing a method of construction that can improve certain requirements, or can meet certain requirements stated by the client. In this particular case, it was a construction sequence. When it comes to structural engineering, it can be from the foundation up to the deck, deciding the best solution. Sometimes maybe using pile or not. Sometimes maybe using monopile rather than multiple piles, and so on and so forth. But the discussion generally goes also in discussing the type of material, steel deck rather than a composite deck, a concrete deck, and finding the best solution. Also, one of the questions, of course, was very correct, was very right. Optimizing the span as much as possible so that form can be reutilized. And yes, there are many ways, of course, to doing value engineering, and we typically when we work with contractor, we work with contractors so that we value engineer the job also for the purpose of construction, let's say, which is reusing equipment that are already been used before. That's a value engineering exercise for the contractor, of course. So there are multiple points of view on this. So yeah.
All right. Thank you so very much, Mr. Presta. Oh, I can see there's just one last question that has popped up. This would be the last question for the session. Can we have an approximate cost comparison between incremental launching and in situ construction?
In situ construction, I mean, on form works. I wouldn't be able to give you the number, but I will probably tell you it's in terms of the putting together you have to build a construction yard in any case, and you need to have some sort of equipment, of course, plus you have to have the launching nodes and so on, and so there are more costs when it comes to, of course, organizing it to build it. But in terms of program, there is a saving in terms of program if you plan it very well, because you can build the substructure while the deck and the construction yard is built. So as soon as the foundation is ready and the piers are ready, you can launch the bridge. And you can understand that a ramp of 550 meters has been launched in 26 weeks. So it's quite a good outcome eventually. So there is some cost, but there is some cost saving in terms of workmanship, of course, where the workmanship is very expensive. It can be important. Traffic, there's no traffic diversion to do, and that's a lot of money as well. So it's difficult to quantify for me in a number because there are a lot of variables. But I have to say that eventually I believe it can be convenient in many ways if there is the right circumstances. I think, imagine if you have to cross a river as an example, no? Building temporary, lots of, you cannot just build in water, no? And you launch you build in the dry and you launch the bridge. It's of course is cost saving for sure, depending on the circumstances, I would say. Yeah.
All right, Mr. Presta, thank you so very much for your time. I'm sure everybody would agree that it turned out to be an extremely interactive session. And I hope that we've been able to, okay, so we have a request from one of the delegates that if possible, and if you can share your presentation, I'm assuming you've already shared with ANSI.
The presentation.
Yes. So we will definitely be circulating it to all our delegates for their understanding. Thank you very much, Mr. Presta, for being here with us today.
I hope it was not too fast, but thank you very much for attending.
Thank you.
Thanks.
And with that, we have come to the close of day one of this conference. I'm sure everybody would agree that, today was very, very informative. And we owe a big thank you to all our speakers for that. And it was also a very interactive day. And, I must say thank you to all our delegates for being very attentive and, for interacting with all the speakers through questions and their comments. I just have a few announcements for tomorrow. We will start tomorrow at 11 a.m. GST and at 8:30 a.m. Indian Standard Time. I would request all the delegates to please join in 10 to 15 minutes earlier, so that in case there are any technical glitches, that can be resolved and taken care of, because we do plan and intend to start at 8:30 a.m. as per Indian time and 11 a.m. As per Singapore time. We will be starting with a short recap, which will be presented by one of my colleagues that would actually, summarize the key takeaways from today's sessions. And then we have about 7 sessions planned for you over the day, which is a project showcase on Cebu Cordova Link Expressway, focus on integration of survey plus BIM for bridge, Australasian experience on the use of weathering steel bridges, focus on methods of bridge construction, Sri Lanka focus, where we'll talk about bridge construction project over the Kelani River, a session on bridge repair and rehabilitation, and finally a session on bridge construction experience, challenges, and key learnings. So that's all from my side. Thank you very much. Have a good day, and we look forward to host you tomorrow as well. Thank you.